Okay, we are live. Is this day 8 or day 9? I think I forgot to update the title to 9, right? Wow. We'll see. Anyways, um, let me post this and post a couple things, and then I'll go over what is going to happen today. 1 second. Dev day 7. Nope, we're good. Okay. Perfect. So, let me tweet this real quick. Cool. So we're all set here. The main plan for today is to actually buckle down and get these networks to work. A little better rested, had some ideas, and we're basically just going to start going through this. So the first thing that I wanted to do was I wanted to grab the parameters roughly from Snake, because this is like just a decent and robust set of parameters, at least some of them. So I went ahead and did that. Let me see which machine we're on. NVIDIA SMI. Yeah, okay, this one. So if I look at the parameters that I have at the moment, Noba config, where is it? Where am I? Oh. I'll show you what I updated these to. So I set these to a learning rate of 0.002, which is very aggressive, but we should be able to get away with this for what we're doing. NumEms 2, NumWorkers 2. Each core is actually running 400 copies of the environment. So really this is 1600 environments. Gamma 0.9, lambda 0.9. These are very good starter values for problems where like it's essentially easy and you get pretty nice dense reward signals. Entropy coefficient of 0.01. This is sometimes enough to prevent models from collapsing, but not high enough to totally crash learning. Horizon of 16 is just default. And then we did essentially 4 mini batches of updates, 32K, very large stable updates, batch size of 128K. And I tried this, and this did not learn anything. So this leads me to believe, and we really haven't seen the agents learning anything reasonable. So I think it's most likely that there's a data problem of some type, because they really should be learning something. Yeah, this is what I ran before. They get this reward of like 0.14 or whatever, which is technically better than nothing, but like this is a very, very easy problem for them to be learning. So we should see this go up to, let me think. Let me see what I have the reward scaled to, actually. So soon. What do I have this scaled to? Where did I define the reward? I think it was scaled to 0.1, but let me double check that. That's very important, the reward scaling. in order to get these models training correctly. Okay, right here. So yeah, it looks like the reward is scaled not at all, so it should just be 1 or between 0 and 1. I'm actually going to double check on this locally. This is on the other box, so add pufferlib, Arments Ocean MOBA. Branch, get push. And I want to pull this down on local. Oh, I'm on the right. I'm not on the right box. Hold on. Yeah, I'm on the wrong box. Great. That's my bad. What's the reward scaled to now here? So, okay, it's the same thing. Yeah, it's the same thing. So, what did I change on this box? 400 copies, yep. Right, and I added a thing to randomly respawn players. That's just like a common debug technique in RL. It prevents degenerate situations from crashing learning. We're obviously going to have to take that out after we debug this. But since this seems reasonable for now, let's see if we can get this to show us what's wrong. So we're just going to print out the reward for the agent that we're playing. We're going to play one of the agents, and we're going to see how the rewards are scaled and if they match up with what we expect. Right here. Okay. This looks good. Does the game render correctly? Yeah, it does render. Okay. So we have a reward of 0.05. I thought we had rescaled this thing to be substantially larger. Did we not rescale this? Player.reward equals previous distance to ancient minus distance to ancient. How do you make the rendering? It's with Raylib. If you haven't seen Raylib, it's an absolutely fantastic project. It gives you just low-level rendering utilities, and it makes it really easy to just render nice stuff in code without having to deal with like a big framework of bullshit or like an IDE or like a game engine or anything like that. The whole rendering for CMOBA. Oops. The whole rendering for this thing here. This is the draw health bars function. And then this block right here, which most of us commented. Yeah, that's like the entire rendering. That's it. It's very, very simple and easy. You can write like nice little renderers in 100 lines of code, couple hundred lines of code. Absolutely love Raylib. Has bindings for every language as well. The original is a single file C library, which is, I mean, freaking god tier is what that is. Why am I getting rewards of 0.05? Is this not compiled recently? We should be getting rewards of 0.5, right? Okay, it was just not compiled. That's fine. So now we correctly get rewards of 0.5 to 1, right? This looks good now. This is fine. So do we just have like some weird issue where we forgot to pull the new... Did we just like forget to pull the new one or something? Or is it not learning? This is good. There's no scaling quantity here. No, it looks like this is legitimately not working, which is what we expected. But okay, it's good that we know that this is the case now at least. So I'm going to run this just to make sure that I didn't totally screw something up somehow while I was half asleep yesterday. And I think we should see a curve that looks like this. So if you get 0.5 for moving in the general direction of the opponent, and 1 if you move along a diagonal, I would expect the average reward to be upward of 0.5 if it's doing anything remotely reasonable. So the fact that it's this low means that it is not. Technically, the average reward should be... What would the average reward be? Well, it depends. I think it's -1 to 1, isn't it? Let me double check that. I think it should be -1 to 1. So if you go towards, it's 1. Yeah, -1. Okay, so this is like a perfectly scaled reward value, right? 1, -1. Yeah, that's like perfect. So if this doesn't work, then there's just something screwy. And it says right here, yeah, this is where it was stuck before at like 0.15. And if we look at the radiant, the positions here, dire X, it's all the way on the right side of the map, so it's not moving. Radiant Y is all the way on the bottom. Dire Y is all the way at the top. And then Radiant... Where's Radiant X? Yeah. So these guys are not really moving. They should be, like, moving towards the center of the map or whatever. So we've got lots of different potential candidates for issues to go through and attempt to rule out here. I'm going to grab 10 copies of the environment. I'm going to go into the forward pass right here, which is where the features are. And then what we're going to do is we're going to render... We're going to run train. And we're going to see if the data looks reasonable as it is going into the network. Okay, CNN features dot shape 800. That is more than I was expecting. How did I end up with 800? Ah, because I ran 8 copies and 8 times 10. Now this env batch size, wait a second, this env batch size does not match up. If env batch size is 4, this should be 400. Did I mess this up somehow? This is potentially something. Oh, it's in demo. Let's look where I make the environments. Train of env batch size. So right here. Args of train gives you env batch size is 4. So it looks like this is giving you the correct... The way that we're making this function appears to be correct. Let's double check on this. Welcome, folks. See, the stream's warmed up a bit. We're doing some hardcore debugging today. We're finding yesterday I got some progress made, but kind of messed around, chatted about a bunch of stuff. Still going to answer some questions and have some fun, but we're absolutely fixing this today. Can relax once we have good models training. All right, let's see what this says. So num workers, ems per worker, batch size. Right. I didn't run this with multiprocessing. This could be a degenerate case because of the serial backend. Right? Let me double check that. I think that I had accounted for this. But it's possible that I could be running this differently locally versus when I'm training properly. It appears so, because when I run this without serial, I mean, if I run this multiprocessing, I get 400 batch. And here I get 800 batch. So quarks of batch size, right? This should be caught right here. Yeah, numems is 4, right? Num workers. Oh, because they're 8 workers. That's an interesting conundrum. I add a to-do here. So not a huge deal. We are going to use the multi-process version for debugging for now, just to make sure. Okay, here we have our features. It's a lot of features. Well, this is weird, right? Maybe, maybe not. Let me check before the encode. Okay, so this gives you... This is weird, right? 3, 1, What are these indices? So 3 is the agent, which is correct. 1 is a tower. Oh, so it's spawning near its own tower. That's fine. Yeah, that's actually kind of fine. How about this one? And then this one is spawning closer to its base, because 2 is a wall. So you have a couple of your agents spawning up near the wall here. It's like random around the fountain area. You can see the wall here, and then the other agent is over here. Maybe this one or something. But not this one, it can't be. Must be this one. So these features actually do look good. These look good to me. Would be very weird not to be able to learn off of this data, unless... So 4 gives you 3 in the center. 5, this should change, yep. So this is now the other team. And then if we go up to 9, it should still be 4. And then if we go to 10, it should be 3. And this is different, a different set of features as well from this 0, right? Yeah. So they are spawning differently, which is good. The random seeding should actually be different here, which is what we want. What else could it be? Hello, welcome, and thank you. Oops. Okay, we are getting some good unique data in here. Do I see any patterns? What's the plan? I'm looking for weird data quirks and discrepancies that would prevent this thing from learning properly. We're trying to debug the policies and get them to actually do stuff. The observation data looks fine to me. It really does. Like, Yeah, this is all exactly what I would expect. This data looks good. So if this data is good, the data is good going into the network. How do I run that snake game and all the other games you created? They're in pufferlib. The command I'm using for these, there's a demo file. If you just do -- help, you get options. But if you run the demo with like -- mode eval, -- render mode, well, there's probably a reasonable default for render mode even. But they're in pufferlib. They haven't been merged up to 1.0 yet, but Snake specifically is in a relatively stable one. Dev branch is relatively stable. If you want to play around with it, it's in Ocean, right there. And you can run it just from, you can run it right from here with the demo file, demo.py, -- m snake, -- mode eval. There's a little tutorial here. Dang, the repo got another bunch of stars overnight. That's awesome. 684 now. Did I mess up the network somehow? Let me see. You get the observations. You encode them. You one-hot them. They get put into this convnet, which is the unreasonable network structure. Get your flat features. You put them into self-flat, which is just a projection. You concatenate them. And then you relu proj relu features. Which is exactly what I did with Snake, right? Snake didn't have these extra relus at the end, actually. And have this extra projection stuff. Grid did, though. The grid environments did. It's identical, so this should be fine. I could just return here to see if this makes a difference, though I don't think it would. Let me make one change here. I just want to see if this thing is somehow screwing it up. Features is cat W2. Let's just do CNN channels. Are you using WSL? Yep. This is WSL, and the other terminal that I have is an SSH into my, well, this is, technically this one that you're looking at now is SSH'd into a server, and the local dev setup is WSL. They're all inside of the containers, though. It's all puffer tank, which is our Docker stack. What editor? This is NeoVim. NeoVim is pretty nice. It is pretty nice. It's basically just Vim with a custom color scheme, and like I have 2 plugins total. So it's pretty close to Vim. The main reason I use NeoVim is just it has easier integration with language model like autocomplete. That's pretty much it. I have one syntax highlighting plugin for Python because that's a little bit weaker by default. And then Super Maven. It's just Super Maven and Semshi. That's literally it. I used no plugins like default config Vim for 7 years. I wish modern IDEs would borrow some of the more advanced macros that NeoVim has. I don't even use it. I don't even use any of the advanced stuff, honestly. I've been using Vim for like 10 years, and I just use it in the dumbest way possible. Like, I use a pretty small set of basic shortcuts, and I mainly like it because it's like, it's portable and doesn't get in my way. So like I have my whole editor inside of the Docker container. So like if I'm deving on a server or on local, I don't have to connect an IDE to the SSH session or anything. It's just there. It's just on whatever box I'm doing, and I have an identical setup. It's really nice. Which version of Vim did you? I have no idea. This is just NeoVim. Yeah, I used VS Code for like a year or so with the Vim plugin, and like it's the second best thing out there, but I still hated it. I like this so much more. People have been trying to get me to to use Cursor. I might do a stream day at one point, but like I've warned folks that it's probably just going to be me shitting on it because I have not found aggressive language model integration to be helpful whatsoever. Did you download the... This is on a container, so this is downloaded on Ubuntu or Debian or whatever the heck container I have here. So no, it's not the GUI version or whatever. It's the setup is in... If you go check out Puffer Tank, you can see the setup in there because it's included. It's on the GitHub, including the config for this. Let me think. So I want to rerun this with... Oops. I want to just see if this does anything different. All I did was cut out a couple of linear layers. Apparently I did that incorrectly. This is output shape, right. I forgot one thing. Whoops. Assuming this runs, I'll check something for you now. Yeah, okay. So while that's running, I'll just show you. I've been actually considering merging this into the pufferlib repo because it's annoying maintaining multiple repos. Mono repo is actually pretty good. Right here is Puffer Tank. And Puffer Tank has our Docker files. These are pushed to Docker Hub as pre-built images, so you don't have to like spend forever building stuff. But if you look in some of these, I think the Puffer Depths one has my... Yeah, here's the NeoVim setup right here. And then it actually has my config in it here. Like, this is literally right here. This is it. It's got like a couple very basic, defaults. And then the rest of this is just hard-coded color scheme. Do I just clone Puffer Tank? You can. You don't have to build the files, though. Like, if you want to use this container, this Docker shell has just a convenient utility. You can just, like, bash docker.sh test, and it will pull down for you the 1.0 version of Puffer Tank. This is like just so you know, this is like a 10 to 13 gigabyte image, but this is the whole dev setup for Pufferlib and all of the reinforcement learning environments that are bound to Pufferlib. It includes PyTorch with like CUDA 12.1, so it's assuming you have a GPU machine. Yeah, lots of stuff. There's a little setup here. There's also a VS Code integration for people. I try to make this stuff pretty nice and easy for people. Okay, so right here I can see that this network architecture change did not help. So this is increasing my confidence that this issue is not just a network config issue. So I think as a result, the smart thing to do PyTorch the only CUDA dependency. I don't think it would be easy to like. So technically, Pufferlib doesn't use PyTorch for stuff, but like the training, all the training integrations make a pretty hard assumption on that. Ziluda. I don't think that there's anything in ML that's easily swapped for those, frankly. You could change it to CPU. You'd probably have to swap the PyTorch install though, because like the container is built assuming GPU. It's built off of a GPU base, so you'd probably have to swap some stuff around. You also don't need to use the whole container, right? Like the containers for heavy RL environments, like Puffer is not that hard to install. You can just pip install Pufferlib, or you can just clone Pufferlib if you want the dev branch. Check out the dev branch and pip install -e dot, and that will just work. Hey, Linky. Thank you for the reminder for the advertisement there. If you find any of this useful, please go ahead and start Pufferlib. It helps me out a whole ton. Really helps me get this work on the board. Linky is one of the Pokemon RL contributors. Doing great work over there. I know I've been kind of AWOL, Linky. I've been working on this project. Trying to make this actually something. Literally install Pufferlib as a dependency. Yeah, it's supposed to be easy, and if it's not, let me know, because it should be. Did you find out what the problem was yesterday? No, that's what we're doing right now. Can I just run a sweep on this while I try to debug locally? I really should have done this yesterday, but I was just exhausted. I guess this does something. We'll see what it's doing, but in the meantime, let's debug more from here. So the observations coming into the network look good. This is usually the biggest source of issues, but it looks pretty darn solid here. So how would I swap and what would I swap? You can just pip and like if you have something where Puffer Tank isn't useful, just clone the Pufferlib repo, check out the dev branch, pip install -e dot. There are instructions on the website and on the GitHub and everything. Let me know if they don't work for you. There's also Discord cord, I can't type, .gg/puffer. That is the Discord for this. Nice and simple. I guess we got to check the environment file very closely now, right? See what's going on with it. Call reset. This is where you assign the actions into the actions buffer. We know that this actually works. We know that this works because we can play the game. Let's double check right here that we're actually getting actions from the model. Let me fix the AC as well real quick. So oh, we can't do multiprocessing here. This has to be serial. $100 actions. Why are there 100 actions? Because I have 10 environments per instance, right? Yeah. That's correct then. So wait. Why did in 64? Does that break stuff? No, that can't break stuff because we've double checked before that. Yeah. Gave me an error, something I can't create or remove file in install directory. I think that's typically a permissioning error. That means that wherever you're trying to do this, you're in some folder that's you need permissions on. That should be not pufferlib doing that. You should just you look up like you're gonna have to like chown that or whatever. I don't know, Linkia. We've never had like weird permissioning errors with puffer, right? That weren't just system errors. Nope. Yeah. Okay. I'm guessing those are system errors. If you think that they're puffer errors, then I will definitely fix those though. This step logic is totally fine. We're able to get rewards back from stuff. Observations, rewards, terminals, truncations, infos. Which are always false, right? Yeah, they're always false. And again, we know that buff observations is correct because we know the data going to the neural network is correct. Yeah, there you go. This looks very reasonable. Like, I'm actually not seeing any of the usual red flags whatsoever for, like, common screw-ups here. If I check the sweep... WSL loves to throw permissioning errors. It's really obnoxious. What the heck is wrong with this? These nice dense rewards. You have what should be a trivial task. Every indication is that the data going into the networks is correct and that the actions are being applied. The hyperparameters are all reasonable. Should definitely be working. We know pufferlib is not like fully broken. How much stuff have I trained since the refactor? I have trained stuff on this branch, haven't I? Non-trivial stuff. Snake seg bolts, really? Why? Well, that's sketchy, right? Didn't seg fault before. No, this is a known good environment. Well, it's trying to launch a client, which is very weird. Though potentially I messed with the renderer. The environment is known good. I'm just wondering if I like really broke some core stuff in Puffer with the latest config. I don't think I did though. Why is it still on render mode human? Okay, so it was literally just the renderer. That's fine. That's clearly training. That's on my local box, by the way, that it gets 700k train. Crazy fast. Yeah, that's definitely training. So it's impossible then that the whole... I didn't break anything critical. I mean, there's no way I would have with the latest refactor. I just changed config stuff. So that learns to play Snake in like a minute. So... how's the sweep going? Yeah, no. Why would this environment be hard? There's nothing hard about it, right? I mean... oh, yeah, okay. What if we only spawned one team? Or we spawned them, spawn player. What if we just made them all be on this team? It's not go to mid, it's go to the enemy ancient. Which isn't really even a debug task if you think about it. Like, technically that could be enough to just play the game. Okay, so this now spawns 10 players on the Radiant team. I just want to see if this does anything different. How does it manage to be that bad? Did I rebuild? Yeah, I did rebuild. Is the learning rate just way too high? Like there should be other signs though if that's the case. No, it just very quickly learns. How bad is the initial entropy crash? Oh. You have very, very clear learning signals here. Very clear learning signals. Hmm. What GPU are you running? My local box has 3080 in it, and each of the puffer boxes has a 4090. Wasn't the recurrent net being weird? What the heck? What's the interpretation of lambda equals 0 and lambda equals 1 again? Hold on. It's been so long with PPO. Looking at the paper. Where's the thing? It's the PPO paper. 0. Oh. Does this do anything? No, none of that does anything. So weird. I was trying to just do a one-step optimization. What the heck would make it this bad? You can use one of the commands like this. You don't have MOBA in that one, but Snake, for instance. We'll pull it up. These puffers are clearly just they're capable of moving around, right? They behave what looks like randomly when they have random neural net weights. They receive what look like good observations. And the policy collapses, even though they should be getting good rewards. Maybe, ADV. Pathfinding is entirely learned, or is there any hard-coded constraints? Pathfinding is learned. The creeps have pre-computed pathfinding. The agents are entirely learning the pathfinding. But the thing is, like, they're not, like, it's really weird because they're not learning anything. And, like, you get a reward of +1 if you go straight towards the enemy ancient. Like, +1, +1. If you take a step in the opposite direction, you get -1. If you stand in place, you get 0. If you take a step, like, half in the right direction, you get 0.5. It's, like, the easiest thing in the world to learn. So, like, there's just something that's screwy, I think. And I don't know what it is. I mean, I have a pretty robust set of checks I normally go through. And they've all come up clean so far. Occasionally, this is just, like, egregiously bad hyperparameters, but I'm starting with a default set that I've used for many other similar simple tasks that have been fine. You're going to have to change the defaults for CPU and stuff, most likely. Undefined symbol is going to be a bad torch version. I think the latest pufferlib uses like 2.4 or whatever. I'd say go download the nightly or whatever, just CPU version. That'll probably fix it. There's something else I'm missing here. I mean, there's something clearly, but I think I'm looking in the wrong place. Like, I shouldn't be spending time suspecting the stable implementation that we've used for, like, everything for the past year. What's unique about this project? And we don't have very many agents per environment. Really, that shouldn't matter. You get very consistent reward. What's the issue? It's not learning. I have a very simple debug task with the MOBA, and it's not learning it. That's the issue. And the sweeps so far haven't found anything better. So I don't think it's just hyperparameters. Sweeping epochs as well? No. Shouldn't have to, but you're right that there was like a weird thing I remember with that. I do remember there being something weird about epochs. Doesn't seem to help. Very, very quickly crashes. What was the starting entropy? Still bouncing around as well. I don't understand how it says that they're getting levels as well. When they have an X of 6.4. Radiant Y at 69 means that they've gone like straight up. Doesn't it? Do I have the agent reset in this copy? Hold on. I'll leave this for now. This is such an easy task now. This is where it gets stuck, right? Yeah. They do better when you reset them. Not by much, though. I do like 32. I didn't rebuild. So they can optimize, it looks like. I mean, you have to make the task so stupidly simple, though. What about why? What do you mean, what about why? This does learn over time now, it looks to me. But it's so... Why do you have to do this? The chords is all internal sim? Yeah. I mean, at least this tells me it's capable of learning. Like, this rules out a bunch of other bullshit. Yeah, this rules out a whole bunch of other bullshit. The entropy is really low, though. Hmm. I have a custom RL environment that's only partially observed. Same. To deal with this, I wanted to use a recurrent PPO implementation, but all the examples I found use convolutional nails for Atari. Can I just replace them with a linear layer? If you have flat observations, yes. Are other changes necessary? No. Pufferlib does that as well. All you have to do is replace the comms with linears. We do that in some debug environments as well for Puffer. Replace all conv layers with one linear or one linear. Depends on the complexity of your environment. I'd usually say if you have some like basic thing, fully connected relu, fully connected maybe is a good entry to your LSTM. May or may not want to put a relu at the end. I think I have relus at the end. I mean, this is what we wanted them to learn. It's so weird. There's got to be a reason for this. Very bizarre dynamic that's happening. So I can get them to learn the thing that I want, but only in a ridiculously, stupidly simplified version. Why? They're getting 0 reward. Entropy bonus? I don't believe it would be entropy bonus. That'd be really funny. Welcome back. Deep in thought here, trying to figure out what is wrong with this. I found some clues this morning. Definitely found some clues. I'm gonna set this to 0. How the gray guys doing? So, if I let them play the game normally, they just learn to go run up against a wall and chill there. It's bizarre. If I reset the agents every 128 steps on average, so they respawn them randomly, they still just go into a wall. If I respawn them randomly every 32 steps, they learn to run at each other down mid. So there's like some incentive that I'm not seeing here. Like there's some incentive that I'm not seeing here. It's weird. No. Well, that is actually better than before. Not really. Little bit. Oh, wait. That's progress. That is progress there. Liked your PhD. Oh, I missed a message. Lone Wolf Design. Hi there. I really liked your PhD presentation. It was extremely interesting. Thank you. I am considering doing some additional long form content for the channel. Tree, they do not lose reward for dying. That's what makes it weird. Yeah, I will potentially do some additional long form content. Nothing as ridiculously high effort as my PhD defense, obviously. But I'm thinking of putting some cool stuff together. For now, I've been just doing a bunch of dev live because, well, there's been a lot of progress since my PhD defense, I'll say. Like, reinforcement learning is practically a different field since then because of all this stuff. I think I figured something out. Hold on. All what's... Wait, hold on, let me... There you go. Okay, I actually got this thing to somewhat train. It's not perfect, but I will explain this in a second. Let me answer these questions. So, are you still in academia after your PhD? No, I'm currently doing Puffer full-time. Puffer is technically a startup, but for the time being, I'm just doing a whole bunch of open source reinforcement learning dev, mostly infra and high performance infrastructure and tools, trying to just fix all of this stuff that makes RL a hard and unfun place to work in. So that's what you're seeing here. Ultra high performance simulation development live and fixing all sorts of things that are broken with RL. So not exactly industry, not exactly academia. I don't really plan on publishing stuff so much anymore because it's just there's a whole rant on that topic. But I do release stuff. I release a lot of code. I do blog posts. I tweet a bunch of stuff. So everything is still out in the open, and all this is open source. All what stuff? Why is it different now? So RL is different because of the level of performance that Pufferlib can introduce and the level of simplicity it can introduce. Like, I would not believe this was possible 3 months ago, and I think that the majority of the field, like, they might tell you now, oh, of course you can do that, but I guarantee you, if you just pose them the question neutrally 3 months ago, they would tell you this is impossible. Like, hey, can you write a MOBA simulator in a week and a half that runs at over 1 million frames per second and trains at like a 500,000 plus on one GPU? They'd be like, are you crazy? No. Yeah, we can just do that now. Okay, so I'm really surprised that the sweep didn't find this, though I probably should have just ran this sweep overnight, because if I let it run for longer, it would have solved it. Actually, has it solved it while I've been talking? That'd be really funny if the algorithm beat me to it. Surprisingly, it didn't. Very surprised that it didn't. What's this thing tried for entropy? I would have expected this one to work. Oh, but it's sampling stupid lambdas. Okay. So this would take a while to find anything good. With Puffer AI, how many agents can you have? Wait, what? Pufferfish go. Yeah, Puffer's fun. With Puffer AI, how many agents can you have? Well, it depends what you mean by that, but the training scale that we're typically looking at for Puffer that I found to be very effective is I'll usually simulate on the order of 16,000 agents. So for Dota, that is 1,600 copies of the game, and I can do that on 2 CPU cores. Typically, we use 2 CPU cores instead of 1 because then we can buffer them so that you're never waiting on data. And the 16,000 numbers because mini batch size 8192 is typically what you want to saturate hardware. You can go much higher if you would like. Sometimes there are reasons to do that. But yeah, you're looking at the level of performance we have now. This on one CPU core, this little mini MOBA runs 5.5 hours worth of games per second. It's very, very fast. And it's very simple as well. Oh, I missed this. Spinning up in Pufferlib would be good long-form content. Yeah, I keep changing it so frequently that like I need to do that once the user experience stabilizes a bit more. Um, like I just redid the configuration system now, and I've got to like rewrite stuff for that. Um, the other thing that's like spinning up with Pufferlib is kind of awkward is Pufferlib isn't a framework. Like it's not some big heavy thing where we give you a whole bunch of first party algorithms and stuff. It's just like, here's a library with some tools to make your stuff fast. Here's some fast sims, and like we have one training demo with a PPO that we have souped up, but like there's not a ton of stuff to it. I did a cool I did a like somewhat prepared demo video. Like I did a demo day video that's the tagged post on my Twitter and is also on the YouTube, where I go through like all of the nice technical advancements in Puffer 1.0. It's a less accessible video, but it's it shows a lot of what I did. Let's try this. Put this to one update epoch as well. One second. 400, 8, 200. Try this. What care do you take for your hair? It's like Trader Joe's 3-in-1. uh, what's the end goal for this Dota style project? Or is it more a test of the libraries? The goal is to have a very complicated and interesting and stupidly high performance environment that you can use for research. Like, what type of research can you do when you have an environment that's more complex and interesting than literally anything else out there that also runs 1,000 times faster? Like, that's the goal. uh, That's fair. I remember you don't like Minecraft ML. I mean, okay, I know the guy who did that one, and he's awesome. Like, my problem with Minecraft as an RL environment, like, here, there's an environment that's called Crafter that I also think is a terrible environment that's like 2D Minecraft. Okay? And now there's an environment called Craftaxe, which is the exact same environment, 2D Minecraft, but like 1,000 times faster. And that environment is awesome. You see, it's like, it just has to be fast. Like, your environment has to be fast, it has to be complex and interesting. If your environment is slow, I can't do anything with it. Yeah, we love... Okay, that's the exception that proves the rule, though. Like, the Craft Axe environment in Jax, that's like 3,000 lines of puzzle-solving madness to make that thing work in Jax. Like, you can actually look at that and say, hey, does this look like a reasonable thing to have to do to implement every new environment? No. No, it doesn't. Like, just because that one guy that did that is really, really good doesn't mean I'm smart enough to figure out how to do it. I like to write dumb, simple code that is fast. Interesting that this one doesn't seem to be optimizing anywhere near as well. This is pretty weird. How this works. Yeah, it's way faster than Mineral. Yeah. Like, the new standard is going to be M's run at 1,000,000 steps per second per CPU core. Training runs at least several 100,000 steps per second. Bare minimum. Get out of here with your slow-ass learning stuff. Like, the thing is, you don't even have to make stuff complicated in order to do this, right? Like, it's not like, oh yeah, but in order to make it that complicated, you need like a 20,000 line RL stack with all sorts of complicated little components. No, like, the environment implementation, pufferlib's vectorization, like, the whole training code, everything together is 3,000 to 4,000 lines. So the whole stack is 3,000 to 4,000 lines deep. Very, very basic and doable. And try this. When are you going to write an efficient Pokemon? How about I teach you how to write an efficient Pokemon and then you do it? Can we do that instead? I've been grinding like simulation engineering stuff for the last 2 months straight, so it's gonna be finish this block, finish up this work block, get right on the Scython. But yeah, pretty much. It's pretty much for me, it's gonna be like finish this work block, get these sims in a good spot, figure out like what I'm going to decide needs to be done for release, like polish stuff up for release. This MOBA I'm gonna hang on to for a little longer. You know, chill for a few days, write a few blog posts, maybe make a couple of videos, like, and then we're gonna go to the next phase of the master plan for RL from there. The goal is pretty much at the moment just to finish all of these first. Interesting that this one doesn't seem to work, where the other one did. What did I do differently? Eight eight four 003. Ten M's. That works? Huh. It's really weird. Do you have any tips on making sims? Yes. Scython is essentially god tier. And if you want a very nice example of how to make something that runs at like 10 million plus steps per second single thread, start on your way in. Helps me out a bunch. So I made... Have you seen the snake environment? Let me find it. Jeez, I've been tweeting a lot of stuff. Where the heck is the snake env? Oh, okay, here. So, snake env. It's snake with 4096 snakes, right? You can also do smaller versions of it. Here's gigantic version of it with lots of snakes. You can do whatever you want in there. Pufferlib environments, ocean, snake. It is 230 lines of wrapper code in Python and 230 lines of Python for the simulation logic. The thing runs over 10 million steps per second single thread and trains it over a million steps per second on one GPU. So this is basically the whole... This is the simple version of how to make sims fast. I added Xfinity for my internet outage yesterday, and they actually reply with this, I'm sure, automated account. That's so funny. Are there any sim examples you would suggest I create? Just to learn? I mean, if you can think of any cool, like, retro game type things, like simple retro games, if you want to add something to Pufferlib, that would be awesome. I did Snake as an example because, like, people know Slither.io, right? And I could basically make Slither.io, but make it stupidly fast for RL. I don't know if there are any other ones that are, like, nice and multiplayer like that. You might have to do single player, which those are a little harder to make fast, though you can still get in the millions of steps per second pretty easily. I'd have to think about that. Are there any old, like, arcade games that would be interesting to do for that? I was gonna do Tetris. I think that would be slightly harder, though. And I don't know if that's a super useful env either for RL. Anybody have ideas for, like, relatively simple sims that would be useful for RL to be very fast? Okay, this is actually training now, which is interesting. So it doesn't train if you have too many M's. That's weird. I'm trying to think of some sims that I would like to have people make. Open TTD, but simpler. Yeah, that's just a hard place to start. I've been wanting to do an RTS. Those are hard. Scaling maze-env, maybe. That's kind of hard to make efficient, though, because when you reset it, you have to generate a new maze, unless you're going to keep the same maze over and over. And that requires a little bit of env generation work as well. I mean, there's like this OpenSpiel thing from DeepMind, where like these M's are fast, but they're not fast when you paralyze them as well. Some of these would be easy. I don't know how useful these would be because this is kind of well developed, if a bit of a pain to work with. I do like the idea of having an RTS, but that's probably a much more complicated project. Checkers and board games fall into OpenSpiel, yeah. Man, there's so many things I'd like to have in this, but like practically speaking, the easiest thing to do. Actually, here's a really good project. Here's a really good project that if you do it well, I'd be happy to promote and I'd be very happy to integrate into Pufferlib. Breakout is a very classic Atari game, right? It's used for like a lot of, it's like the cover for a lot of old RL research. If you were to make Breakout at 1,000,000 steps plus per second, then we got it training like in 30 seconds or something. I think that that would probably make people very interested. That was something I was thinking about doing that's like pretty easy, but I don't know if it's worth spending a few days on it. That would probably be a pretty good learner project, assuming that you're like a competent programmer, may or may not have tons of RL experience, but want to do super like high perf sim dev. That would probably be my suggestion to do. And yeah, if you look at the snake stack as well, like you don't render breakout during training. Like you would just give it like the board would just be represented where like each like pixel or whatever is a block, and then your paddle is a certain like length or whatever, and then you would just render it at test time. You'd like make it playable. That wouldn't be that hard. I would expect that that project would be probably about the same length as Snake. That's probably a whole, like, you can probably do that whole project, maybe a little bit more for the rendering. That's probably a 500 line of code project. What are the current steps per second for breakout? It's actually hard to say because we've got all these crappy Python wrappers that make it slower. I think it's actually like in the tens of thousands or like high thousands maybe. But then also because it's rendered, like you have just a whole bunch of data that has to go through the neural net that slows it down. Whereas if you could get more efficient state-based, that would be more useful. Like there's RAM-based stuff, but nobody really trains from RAM because that's kind of weird. But yeah, if you're interested in doing stuff with Pufferlib, that's like the exact type of thing that I suggest to people. Like if you want to like get your feet wet with development in this, like, and you want to contribute to this space, like new M's for Puffer that are like, you know, built well, stable, high perf, that's a really awesome way to get involved with it. What tools should I learn to make such environments? I just linked the Snake project in Pufferlib. If you just look in the dev branch of Pufferlib Environments Ocean, the Snake game is an end-to-end example of making Snake in 450 lines of code that runs at over 10 million steps per second. It's just Python plus Python. That's all it is. And like you'll see the way that I use Python to mirror arrays back and forth between Python and C. Yeah, it's a pretty simple stack. It's like actually shockingly simple. Okay, so here you can see different games that have been won, it looks like. The reward capping out here is a little odd. Check out the Snake implementation. It helps I can reach out on Twitter if I get any progress. Yeah, of course. You can DM me on Twitter. You can at me in the Puffer Discord. You can find me here. I'm not hard to get a hold of. 10 million steps per second. I think it's a little more than that, but yeah. $10 million for something like Snake is very achievable. For something much more complex like the project I'm doing now, you can still get over 1 million. And like I think you could get AAA level games still potentially running in the hundreds of thousands. You just have to build for it. 2.89. Weird how this gets more stuck, isn't it? 0.24. Why does this get stuck? Oh, you have a very different... Very finicky. Check out those. What's this? 1 second. Is pufferlib meant to be cloned like cleanRL or installed via pip? So if you want to use our training utils, they're based on cleanRL, so you clone it. If you just want to use the environments out of the box, then it's a pip install with the understanding that like all the new sims that I've been building are still in dev branches. So like those aren't in the pip package yet, right? But like all the existing bindings and stuff are accessible via pip. So it's a little bit of both. I want there to be a stable package that you can use for like our core vectorization bindings functionality, right? And then for training, it's got to be a clone because we base it off of cleanRL. So, that stuff is in user space. And really, like the idea behind pufferlib is if you're trying to do advanced stuff with it, it's intended to be white box software. So like the goal is that you should be able to read through any bit of pufferlib that you want to like look at, extend, or do stuff with, and your eyes should not bleed. Interesting how this works. 4 update epochs. Did I just like find the YOLO config somehow that just works and nothing else does? It's a really ridiculous amount of data reuse. So when I want to run a custom env, I should clone. It depends, right? If you want to train a custom env with pufferlib's training stuff, then yes. If you want to just use a custom env with pufferlib's emulation layers and vectorization, then you can do that via pip. Because you just use like pufferlib.emulation.gymnasium puffer env of your environment, and that gives you a pufferlib compatible one, and then you can use like pufferlib vectorization multiprocessing, and then you have your high perf simulated environment just like that. What does it mean when an array has an Okay, it's not inhomogeneous, it's heterogeneous. And what that means... Well, first of all, the thing that you asked doesn't make sense. I assume that you mean non-homogeneous or heterogeneous observation and action spaces. And that means when different agents have different shaped observations and different shaped actions. That is something that is fundamentally very obnoxious to support because you get variable sized arrays everywhere. And yeah, I don't want to have to deal with that if possible. Setting. Okay, so you're just, I don't know where you're getting that from, Linky. Horrible obs. I mean, that stuff is part of Puffer's advanced API for a reason, right? It's because it's not easy. Dire X, Dire Y, Radiant X. What is this thing actually doing if I look at it? Okay, this is actually fairly reasonable. This one being stuck is weird. And them not figuring their way around. Hmm. So the main thing was entropy. Very weird. Well, this definitely appears to be working. Professional, bottom left. Oh, look, he went this way for once. That's funny. Okay. Out of memory. Something weird happened with this. Okay, so these things do train now. It's just some weird quirk with the render library. Don't worry about it. I'll find it at some point before this is launched. The leak is not in the simulation, I checked. And it's impossible for the leak to be in the simulation anyways. Can you layer games? Linky, I have 1,600 games going on at the same time, not 3. Though actually, oddly enough, it doesn't work well with 1600 games. It works better with, what's this? I think 80 games. Yeah, it works better when I have like 80 games. It's weird. There should be no reason for that as well. So I'm going to try that next after this. We're not going to spend like all day screwing with just the really, really basic version. Um, the plan is to finish this, do a little bit of analysis, fiddle with one or two more things, and then we're going to work on like proper observations and stuff for this game, and then like code improvements, balance, like actual moving forward on the project. And then like the rest of the experiments will basically just be done via sweeps. You need to get the environment to a point where you are mostly getting something reasonable as a starting point, and then from there you can automate everything else. Getting the reasonable starting point is just sometimes very obnoxious. Well, it does actually look like the model's getting a little bit better over time, maybe. Let me see. A little bit improvement right there. That's weird. Yeah, definitely. You can see it spiking. So we'll finish this. We'll pull this model. We'll see what it looks like. We will fiddle with a few parameters. I'm only logging the stats. These stats, except for the reward is everything. But these stats are only from the first game. So these like spikes here whenever it finishes a game. So it looks like each separate environment is only playing like whatever this is, 10 to 20 games. Are we crashing? No, we're good. There's definitely some weird dynamics going on here. RL still got some demons. I haven't purged all of them yet. That's what the exorcism's for. The other thing I wanted to do was just train with more M's, right? Yeah. And from here, be a lot of stuff to figure out. Puffer. Does Google use RL? Does Google RL? At what point they use RL? Yeah, pretty much a lot of the big tech companies use RL, at least for some stuff. A lot of it's RLHF these days, which is like, I don't know, baby mode RL for noobs. No, seriously, it's a hard but different problem that has different characteristics that doesn't really make it RL in the traditional sense. But yeah, it's been used for a bunch of applications at different companies. Obviously, nowhere near as much as language models, but RL has not had the same level of investment and maturity yet. DeepMind, part of Google. Yep. DeepMind uses a bunch. I'm going to be right back while this job finishes up. There's a restroom, be right back. And then, I mean, at least we have something working somewhat now, right? Once you have something at least you know is training and you know isn't just like horribly bugged, it's pretty easy to improve from here. So I'll be right back. this finished. I don't think this is necessarily any better than the other models. Actually, is entropy full crashed? Let me see. Well, to be fair, if entropy is full crashed, it doesn't matter because we literally have no entropy bonus. No, it's not full crashed. Pretty reasonable model. It actually does occasionally path around walls. Sometimes it gets stuck, but usually paths around the walls. Sends it down mid. Pretty reasonable overall. Doesn't really stop to fight because we turned the XP rewards off, sure. But overall, I'm pretty happy with that. I've even seen him go down a different lane once or twice. Yeah, like that one right there on the left. Went down the top lane and then went into the jungle. Pretty interesting. Okay. So the only other thing I really wanted to do was I wanted to see if it was really the case that where'd this go? I wanted to see if it was really the case this just doesn't work with more environments. Because there really should not be a reason that it wouldn't. So this is going to be now 200 Ms, I think, right? Config MOBA. Let me just back of the envelope. And MOBA. So we've got 8 Ms. We've got 4 per batch. 4 per batch means that we need 200 Ms each. Yes, because that gets you 800. Yeah, that gives you your 8K mini batch. You have 8K times 128. That should give you your BPT horizon of 16. It's probably very low for generalized advantage estimation. That could be an issue. Yeah, but let's try this for now. Why not? Right. Okay, so regardless of this, we need to start on the rest of this project now before I get bored and tired of this. So, let's see. We definitely need to add some stuff into the observations, right? Right now, you can essentially observe the nearby entities, what team they're on, and what type they are. You can't observe health, mana, anything like that. Sleepy did lots of work today, so sleepy. Good night. Thanks for stopping by. I'm gonna just keep hacking on this and trying to make add some stuff to the observations so that the models can be better. Mess with some rewards, stuff like that. Chief Puffing Officer. See you tomorrow. What do I do here? Do you want to be able to observe X and Y? Not really. There's not that much stuff you need to be able to observe, right? What did they do for Dota? Model architecture should have. Because they did a whole bunch of stuff, but I don't think a lot of it is crazy relevant. You need to know something about your skills, right? So, heroes only. Okay, so they've got like modifiers, abilities, and items. Yeah. That would be nice to have, right? And then they have unit type. Whether it's under attack, stats, health, distance. They have an orientation, absolute position, and animation. That's because they don't do a CNN. Interesting that they went with this. I know why. It's very hard to do something like this. We're going to go a little simpler than this, for sure. I think we can probably... The one thing that's a little bit obnoxious here is we have to like normalize stuff to fit in one byte. The way I have this at the moment. So, yeah. How many of these things are discrete? You definitely need to observe health, mana, damage, modifiers, maybe, timers. You only get to see your own cooldown timers. This is not that bad. How's this experiment going? Not well, that's funny. That's very weird. Yeah. Potentially there's still some issue then. Though I think I have some better ideas as to this. Okay. We're gonna actually wake up a little bit here and do some proper dev on this. So for observations, we're gonna have to change the way that observations work a little bit. It's observations map. Observations map. Yeah. Observations map, observations extra. Right, the way observation map works at the moment is that each player gets a 2D grid. Now we need to give each player a 3D grid. I have to be careful not to blow up the data here too much though, right? Ooh. That's potentially rough. Not blowing up the amount of data. Because right now it's 150-ish, 200 bytes. And we've got some continuous values. I can't add that many channels to this, because they're going to be very expensive in terms of memory. It's 11 by 11 right now. It's 121. If I'm really selective with these, right? You do need to see their class. Their class, right? So let's say we do classes like we roll that into type or whatever. That's just 1 byte. We'll discretize health. Do we need to discretize mana? Probably should be able to see the opponent mana. Say we discretize health, mana, damage. Do you need to be able to see damage? Not really. You know how when you're getting hit. If you know their health, you know roughly how strong they are. Do we need level? See the enemy level? Again, not really. You should know based on... Well, no, because if you don't know max health, right? If you don't know their max health, if you just know their current health. I think we do health, mana, level. What about modifiers? Not really. Maybe you want to know remaining stun duration. You can't even see that in Dota, can you? You just know how long your stuns last, don't you? There isn't like a... Is there a cooldown timer on them? I thought you had to keep track. Yeah, you can. Is that the case in Dota and League that you can see remaining stun? It's a white bar, okay. So I can add them, I just don't know if it's worth it. So let me make this clear here. Everything that we add, oh, it's a newer feature. Okay. I don't think we need that then. So here's the thing that we gotta deal with, right? This project is complicated enough as is. I have really fancy encoder tech I can use to compress observations. I'd rather not have to use it here. This project has enough other stuff going on. So naively, and I'm going to do a little bit of compression already. So naively, every new feature that we want to add adds 121 bytes to the observation size. So right now that you can assume that the observation is going to be between 150 to 200 bytes at the moment. And every additional feature we add adds an additional 121 bytes. This is not going to be a problem for the neural network, but it is potentially going to add bandwidth, like data transfer bandwidth, that can slow stuff down. So we really want to limit this to like, what do you need to play the game? You definitely need to be able to see what type of agent everything is. So you need to be able to see like the class type and like the minion type, the minion team, that sort of a thing. I can do that. That's fine. You need to be able to see health and mana. I'm going to omit max health and max mana as unnecessary. You need to be able to see the opponent's level. And probably that's about it. So we had 4 features. Or was that? Did I say? So health, mana. I said health, mana, and level, right? So that's a total, plus the agent type is 4 features. That's a reasonable size observation. That's a relatively small amount of information for me to have to deal with. That gives you a lot of data, actually. Shouldn't be too difficult to deal with in the neural net side. And then for yourself, you'll get a lot more information about yourself. Yeah. How's this experiment going? Well, it doesn't matter. I'm gonna go get something with a little bit of caffeine in it. I'll be back in, I'm gonna be back in like 2 minutes. I'm gonna just wake myself up because we're gonna do, right now what we're gonna do is we're gonna get the observations that we actually intend to use for the game. That should enable the models to do way better. And then it'll just be a matter of like reward, game balance, and that sort of a stuff, and cleaning up all the game code. So this actually will have us in a pretty good spot if we just do this today. Be right back. Okay. Let's lock in. We update this to be 4-dimensional first. Obnoxiously, we have to 0 this whole frickin' thing, don't we? Observations extra, we're going to leave this here for now. We go through these nearby agents. Which I think we can literally do a scan on, right? Regardless, though, target is get entity. Target ob, we don't need this. We do need dx and dy here, actually. I remember why I needed those now. So we'll do int dx and dy. Ooh. Kind of gross the way this works. R is going to be equal to y plus dy, right? And then we need to know target PID is going to be PID map at this location. We actually know R is going to be a little different from this. It's going to be plus dy. It's just going to be dy plus self.vision range, I believe. Right, because we want R into X. Hi again, Kawa. We're doing features. We're doing proper features for DoTA now. So we're expanding the observation map to include additional data. Okay, so now we have the location. We have the local location in the observations where we want to add this thing. Let's do get the target. We can filter here. Don't need to do this processing for non-existent targets. And then what we do is self.observations map of PID row call 1 is going to be equal to target dot health. And then mana. And then we want level. You can see their health, their mana, their level. Rest of this is garbage. We break. We do not need this IDX garbage anymore. We do not need to sort by distance. We will find out an alternative targeting mechanism, I'm sure. This is quite clean. Observations extra is still fine at the moment. I would like to modify a few small things here, potentially. But I think we'll start with this. Yeah, let's start with this. We have to modify the network architecture just a little bit as well. This is now 8+3 channels, right? So we do map features is going to be the observations, or CNN, what is it? Why aren't you using an IDE? I got NeoVim. What do I need an IDE for? It's not like I've never used an IDE. We only want the first channel of this. Yes. So now we have map features, extra map features. So, oops. CNN features. We're going to concatenate these, and then we're going to pass these through the CNN. So now we have something reasonable here. Would you say that clean code isn't always... If by clean code you mean the clean code like the book, that's an anti-guide. That's like how to develop terrible software. Cannot reshape array. I really should stop screwing around with these like hard-coded in 4 places array shapes. We're just going to do obs map bytes is going to be equal to, what did we say? Ob size. That's also a parameter. Okay, we'll just do self dot map bytes obs map bytes equals self dot ob size times 4. And then wherever I'm using this, I can do self.obs map bytes. What I'm doing here is I'm adjusting the observation spaces to accommodate the additional data. We're now going to have 484 bytes worth of observation data per agent from the local map that tells you what agents are nearby. And now we've added to that we have the health of nearby agents. For heroes, you get to see their mana and level as well. So those are quite expensive in terms of memory with this representation, which we're going to have to see how bad that is. But the benefit of representing it this way is we don't have to do any decoding or additional stuff in the forward pass of the neural network. It's very, very simple to use the data from there, and we don't have to offload any processing over there. So I think that this should be good. There may be some oddities. We'll see. Dot observations shape 487, which is perfect, right? Cannot reshape into shape 10. Right. 4. We good here? Yes. Okay, now we get buffer has wrong number of dimensions. Expected 3. Got 4. That's just, we didn't recompile our code. No big deal. Right, I forgot some data type shenanigans. We need to do, target mana and stuff now, don't we? Do we want to do this as a percentage? We probably want to do this as like a percentage, right? Hard to say. How do I want to encode health and mana? I think as a percentage will be cleaner. And then they'll just have to learn that, like, hey, if this thing has a giant level advantage on you, you're probably going to get murked. So we do float target.health. Is health a float or an int? Oh, it's already a float. So we're actually, we're chilling. So we do target health over max health, and we just do 255 times 255 times this, and then we'll just cast to unsigned char. So now what we get is we get a value from 0 to 255 that tells you the percentage of the health. And the reason that we're doing this is that we're trying to pack this value into 1 byte. So we can do the same thing here. And then we can do the same thing here. Unsigned char target.level divided by 30.0, which is the maximum level. Perfect. And cannot cast type double to unsigned char. That's funny. I forgot that you have to do F. Are you not allowed to do F like this? 30F. How would say a float in Python? Sure, it was just F. It's kind of weird. This work? Cannot assign type double. And how would this possibly be? Assign type. Oh, is it just this? I think I just needed this set of parens here, right? Yeah. And now we have cannot assign float. I forgot that this is like, it binds tightly, I forgot. I haven't done C-style cast in a while. Makes sense. Okay. This compiles. What happens when we run train? Differing extents in copy contents. 4 and 11. This needs to be, oops. We need to add this as well. Rebuild. We're going to have to redo some optimization after this, but that's fine. So much stuff to fix. View size is not compatible. Yeah. Oh, well, I think I just did this. Yeah, I just did this wrong. Right? View -1, 11, 11. Yeah, I just did it wrong. This is now -11, 11, 4, I believe. Okay, we get a CUDA. CUDA's mad. Wait. Oh, okay. Right, before the one hot. Because you didn't slice. It's... Okay, we got the one hots. We got our extras. Must match exactly. CNN features. dot shape 0, 1, 2. This now has to be concatenated along dimension. This is dimension 3. And I think that fixes it. Apparently not. Oh, I might be missing a permute, right? Extra map features. This is totally wrong. Colon, 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 negative. Star. Yeah. But then there's a channels permutation here as well. Just tensor shenanigans. I'll be sure to have this nicely cleaned up for the release of it. Too many indices for tensor of dimension 2. Yeah, so this is actually got to be, this is CNN features, colon, 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 3 star dot float. Okay, so now we have our extra map features and our map features dot shape. And we still need to permute this, it looks like, because we do channels first. So this is actually dot permute, which means that we're stacking along the first dimension. Let's see if this gives us our features. We're looking for 11 channels worth of features, I believe. Must match in all dimensions. Okay, apparently not. This looks good to me. Map features. CNN features. Oh, wait. So we want to concat map features and extra map features. So I had it right, I just had the wrong names. Okay, perfect. CNN. So this is now a very good representation for our network. We have 11 channels of 11 by 11. There's nothing special about having it be a cube like that. It just happened to work out that way. But now, how much data is that actually? 800 times 96 KB. 96 KB per batch. Not bad. And this seems to now, this seems to run. Yeah, cool. Our network runs now. And I'm not going to start training just yet. What we're going to do is we're going to clean this up and allocate some additional extra variables. So the architecture for this at the moment is that you have some number of things that you can observe about all of the agents around you. You can observe everybody's health, everybody's mana, and everybody's level. But then you, of course, you have some extra information, like your cooldowns aren't visible to everybody and stuff. So we're going to add those into an extra vector that you just append on at the end. We're going to have to change the shapes as well. So we may as well just do that. I don't know, 10. We'll see how many we end up using. So yeah, this is your shape here. It's a little bit obnoxious that they have to be Uints like this, but it's fine. We bite pack. Where else do I use this? I have it in the observation space. It should be in the buffer, right? Yeah, right here. Okay, and then there are a couple other places where I have this thing hard-coded. So we'll just swap that out now. I think underscore fill, yeah, this is a dead method, right? Because we have this in C, which is better. Better, faster, stronger. Yeah. Do I have threes anywhere else? According to this, I don't. Right here, yeah, there was one more. Cool. So now we get to allocate these. We'll have to pick which variables we want to include. I think that for yourself, you get to see your pretty much most of these. We'll find a better way to copy them later, I'm sure, but to start with, these are right now, they're just added right here. So we're going to add in your X, your Y, your reward, which this is wrong at the moment. Ooh, how do we do this? 27. 255 values. If we limit rewards to -1 to 1, hold on. Let's say -1 times 128 plus. Can't do plus 256. Wait, -1 needs to map to 0, so it should be plus 128, obviously. And then 1 times 128. This is 256, which is too high. This is just an asymmetric problem, right? There are 256 values. So you can't have 256 values and distribute those evenly. I would like to scale this perfectly. Kind of important. This gives you -1. Oh no, gives you 1. So that's perfect, right? You never get 0. But this is fine. So we just do 127 times rewards plus 128. X and Y are also fine. I think you can even multiply these by 2 times, because they're 0 to 128. And they'll never actually be 128, so you're safe here. So now we're going to do health and health and everything, right? Level's fine, actually, here. We don't really need XP. Do we want to see max health? I think that we're fine just doing it this way. We give you mana. We've already done level. We can do damage. Plus 6 times player level. 30 is 180. So your damage is never over 255 in the current format. We'll make sure that we add bounds checks. So unsigned char player damage is approximately in the correct bound. Move speed. Move modifier as well. We do the stun timer. Is that everything? Is hit, level, attack cooldown, basic attack cooldown, which is like going to be 50 times this. Basic attack timer is also 50 times this. QWE timers, these are fine. Okay, I think these are like reasonable to start with. And potentially we will do auto scaling instead of manual scaling here. But the thing is, like, because we're discretizing, we Yeah, because we're discretizing here, it kind of makes sense to scale it myself, because some of these values are floats, though maybe not. Maybe I don't have to. We'll see. But this is all nice data. So we ended up with 17 different values here. So we'll set this to 17. And we will edit the we'll edit the network as well to take 17 input variables. Right. Okay. It appears to work. This is minus 17. So minus 3. Okay, so that was relatively painless. Now, in theory, we have all of the data that we need for training. In practice, we're going to add a few additional values, I'm sure. But this should make quite a big difference already. Now, it's not going to make a big difference in the current training task because it's very basic. We also, I think the next thing that we need to do is we need to make sure that players can tell their hero class. That's a big thing. And that's also going to be important for the renderer. So let's do that next. We'll do int radiant creep is 3. Dire creep is going to be 4. Neutral is going to be 5. Radiant. What order did I define these things in? Support, assassin, burst, tank, carry. Support. When I say radiant, support, assassin, burst, tank, carry. Carry. Okay, and we forgot the tower as well. The tower needs to be int Should I distinguish these two? Or should it just be like tower? Probably easier. No. The icons on the map can be the same, right? Oh, wait, we already have tower. We have got tower empty. Really, it should be empty. Let's do wall is 1, tower is 2. Creep 3, 4, neutral 6, 7, 8, 9, 10. Dire. What's up with the autocomplete today? This actually fits perfectly into 16 values. That's very nice to have. So this fits perfectly. Minus the debug one, which we'll ignore for now. Here are all the different creep types. This will allow us to do a bunch of stuff. We'll do support, 0. We'll use these as well. Type, class. Can't do class. Hero. Cool. Yeah, let's do that. If player.type weird how I have this done. Player.type is entity player. Oh, I see. Yeah, there's like a lot of different typing information we got to get right here. So we've got int pid. Let's make sure we get this right. So this is going to be entity type. Hero type. Grid type. Grid ID, hero type. So this is then team type. Any type, hero type, grid ID, team. This is fine. And we're going to have to change quite a bit of stuff from that. I think it's probably best to just go through very slowly. Nothing should be here. We're going to have to change a lot of stuff, though. Probably in the move functions mostly. but I don't want to miss anything. So first of all, in the observations, does anything change here? Not yet. We're going to add a few things to it later. Spawn tower. This is now tower. Entity type is going to be entity tower. Tower.grid. ID is going to be tower. How much stuff do I want to give different IDs to? What stuff would I need to have different graphics? That's kind of the test. I think you only need the 16 grid IDs I defined. So this is tower, this is fine. It's got PID, should be up top. Yeah, that's fine. So now reset does player.pid, player.entity type. Player.grid ID should be player.grid ID. Oh, I actually have to do this normally, don't I? Player.grid type has got to be Radiant. That's a support. It's not Radiant player, is it? No, it's Radiant support. I don't know why it can't autocomplete this. Radiant Assassin. Carry. At least it autocompletes off of this. Dire support, assassin, burst, tank carry. Perfect. That takes care of that. And we'll probably adjust the values as well for all of these in there, because we're going to have different max healths and stuff per class. We might even add different scaling per class. Probably will. That'll be fun. And we're probably going to move where this code is for now, but this is not bad to have like on initialization, to just have like all of the hard-coded values for all the different types of things you're initializing. This is really not a bad way of doing it. Yeah. I'm actually tempted even to like, I could go through and initialize all the creeps like this even, maybe. That might not be a bad idea. Then when you reset creeps, you literally just move them. We'll start like this, though. Player.team. Okay. I think we're jamming this now. Hardcode the lanes. This is just for the scripted AIs, but we're going to do, what did we do? 0 and 1 is 2. So we'll do player.lane 2. These are all 2s. And then lane is 4. This gets a 1. And 3 is a 0. Perfect. Player lane is 3, 3, 9. I don't know why it can't copy data. Like, seven's got to be a 4. And then 8 should be 5. So these lane assignments don't actually do anything when we're not using the scripted model. But very nice for the scripted model. Okay, that's actually a lot nicer. I'm way happier with that now. So we're actually kind of cleaning stuff up in the process of doing this, huh? And all this agent type stuff, we literally no longer have to care about because it's literally now just player.grid ID. So this gets deleted. So this logic that runs every single time anything moves anywhere no longer needs to happen. And now the move to function is actually very simple. It's just a sanity check, move on grid, and then move on the PID map. I don't see anything that needs to be updated here. The spawn needs to be updated. Entity type is entity neutral, right? Grid ID gets neutral. And that is fine. And then it gets to be team 2. Which is not anybody's team. I don't see any logic to update there. There will be a little bit to update in spawn creep. Entity type is entity creep. We'll do creep.grid. ID is going to be creep.team, creep.team. And this goes away. Respawn player doesn't touch any of those attributes. Respawn creep doesn't touch any of those attributes. Target.type no longer exists. This is now entity type. It's entity player. Entity type. This is fine. Entity type. There may be some additional type checks in here, right? Like over here. tower type, so I assume there's a get type somewhere here. Type. Here, we need this as entity type. And that might be all of them. These are just skills. They shouldn't be checking any of this, except this one apparently does. Entity types. Type. Dot. Player dot type is not in here. Entity dot type is not in here. Creep dot type and neutral dot type. Target dot type. Okay, I think we're good. This is a substantial change, so this might take a little bit of figuring, unless I one-shot it. Likely the rendering is not going to make sense for a little bit until I update the graphics and the colors assignments. Mode render or eval. Render mode Raylib. I think actually this will crash because, yep, we don't have enough colors, which is fine. So let's just take these grid IDs and let's go to environments in MOBA. Let's just get some nice colors for stuff, right? Empty. Then this will just be 0 to 55. The walls are blue, I suppose. Don't really like the walls being blue like that. I would rather use, is it 178? 78. This is the puffer color. Tower is going to be... Tower is going to be an objective marker. Let's go get a color picker up. What do we want the towers to be like? Orange? Green? Green for the objective markers would stand out nicely, right? So it's tower. Radiant creeps. Oh, we need a color identity for each side, don't we? What do they use in Dota? It's green and blue. I mean green and red, isn't it? For the creeps. Yeah. So maybe we don't use that for the tower. Green plus red is orange, so orange. Code. FF. One, 6, 5. So this is the tower. Radiant creeps will be in, I say dark-ish green, right? Darkish greens and reds, maybe. Dire creep will be dark red. Neutral creep will be gray. And then initially for radiant, I think what we do is we use, do we use tones? This is, nope. Need like some good colors for the creeps. Oh, we did let's actually change this up a little bit. We're gonna change the default colors a bit from the originals, because red green is bad for colorblind, and also it's like we're gonna do red, white, and blue, because of course we are. So radiant creeps will be they can stay. No, these need to be dark blue like this 128. Yeah, so it's red versus blue. That's better. And then we'll just give you like cyan versus, that's even better. We do need to get you a color palette, though, for the heroes. They need to stand out quite a bit. Still doesn't solve this problem. I do get to use all of the bright colors now, though. I could do dire creep in 128 like this, like dark. And then I could just make these. For now, I'm gonna just make them like the pure colors. Okay. And then for now, we'll just do, is it 0, 0, 255. All right. This should be a reasonable color palette. See if we can see anything. CUDA error. Device side assert. Yes, because now we have to change this to be 16. We have 16 possible channels instead of 8. 16 plus 3. Gets one hot with a max of 16. It looks like I messed up some color codes, because this is not what I intended, though it's very funny. So let's see, how did this happen? Oh, because I think we're using these maybe. Where's the wall thing? Wall is now 1, and tower is 2. Not need to do this. Okay, let's see about this now. There we go. So the walls, the colors did not come out great. Yeah. Because we flipped, first of all, we flipped the radiant and the dire. So let's undo that. It'd be 0 to 55. And this one is 255, 0. See how this looks. Okay, red versus blue. Way better. Yeah. Creep colors are off. Let's do dire creeps are just going to be 128.0. Radiant creeps will be this. Let's see if this looks better. Oh yeah, there we go. And we'll have to come up with a better color palette, but for now you've got dark red, dark blue. Can you give a quick rundown on what is being solved here? If you've, this is the first time that you're seeing this project. This is a miniature version of a MOBA. It's based off of Dota, except that it runs at over 1 million frames per second. And the goal is to train reinforcement learning agents on it to play the game. So you essentially have, if you've seen the OpenAI 5 project, where OpenAI trained, well, they used a ton of compute, like tens of millions of dollars of compute, to train agents to play the full game of Dota. We're doing a mini version of that, but we're going to make it like 10,000 times faster. So you're going to be able to train this on one desktop. And I'm building the simulator. I am figuring out what data to pass from the simulator to the networks. And what I'm doing right now at this particular moment is I redid the way that the environment represents different types of agents, different heroes and such. And I had to fix the renderer so I could actually see what's going on. And then now that this is fixed, I'm going to be passing all that new data into the neural network, which will hopefully allow the agents to better learn how to play the game. That's what's going on here. Ultra high performance simulation engineering for reinforcement learning. Ultra high perf. Does this RGB array renderer take colors? One sec. Just want to make sure the other renderer is not broken by my new change. RGB array renderer does take colors. Yeah, okay, so this one works as well, just the same. Perfect. We fixed the renderer. Now, let's see if there's anything else we want to include in the agent observations here. Only thing I can think of is, do we want to include the hero class? It's not really a format of data, a data formula that's going to be useful. I could add it as 5 separate variables, maybe. How far are you going with modeling? How many champs? They have a simplified kit. How many players? It's a 5v5. The map is currently modeled like 1-to-1 with the Dota map, except I've only implemented obstacles so far. I haven't implemented the forest or vision or anything like that. They do have a simplified kit. They're not 1-to-1 with the Dota heroes because the abilities that many Dota heroes have are very complicated and really require you to implement a lot more of the game. So they do have simplified kits. I currently have 3 skills per hero. I'm thinking about adding, ultimates and stuff, though they're harder to learn to use. So they're 5 unique heroes. It's a mirror match, and it runs really fast. And we can continue. I mean, I can continue to build out from here. I've only been developing this thing for less than 2 weeks. It's mainly going to be based on how interested people are in this project. So the current plan is to make this like mini MOBA that can be learned with the reinforcement learning, get some baseline agents that train to do some interesting stuff in the environment, make sure it's very fast, very clean, and very easy to use, and then release it. If people think that this is, if people are very interested in this project and want to see like more specific stuff added to it, then, I will go ahead and do that. Okay, so far this is pretty reasonable. This rewards variable, I think we want to move this. I'm going to move this down here. We're going to have to reindex everything. Thank you. It's all open source as well. You're free to download it and play with it. Whoops. this works. So we have to maybe just add some indicator values, right? They should know their team as well. So let's just add a few additional things. Team. We didn't add team, right? Yeah. Let's add team. $255. 18, 19, 20. Okay. So we've got some indicators. We now have 22 variables associated with the player. We should probably put a little bit more effort into the scaling here. Unsigned char player.level divided by 30. Should be 255 times player.level over 30, right? Yeah. And then the timers we don't know yet. Player is hit, player.team. These look fine. So 22 variables. Oh, 23. It's got to be 22 right here. We're probably going to want some different reward components, huh? Yeah, we're going to definitely want some different reward components. Maybe what we'll do is we'll make each individual reward component between -1 and 1. Yeah. And then you can always scale the reward, right? Well, no, that doesn't make any sense, come to think of it. I think we leave it here for now. We start with this. Welcome. We are currently adding a whole bunch of better observation data. We're adding a bunch of better observation data into the model. We currently have four channels worth of map data that contains information about the map itself and nearby heroes. And now agents have 23 variables about themselves that they can see. So this now goes up to 23. And this is player obs n. Where is it? So this is now 23. 23. 23. Does this run? This does run. About the same speed as before. Perfect. Let's commit this up and see if we can get something to train on this now. Upper lib. Okay, so now we have the latest code. Diff 200 Ms. Okay. So I know 10 Ms worked before. I'm going to set this to 10 even though it's going to be slow. That's fine. Yeah, this is fine. So let's run this. We have to run setup. Does this run train? It's very slow, but it's very slow because the small number of environments. That's acceptable. It does appear to be training like it was before. Yeah. Oh yeah, there it goes. So this should just run down mid. It's a very dumb model that we just trained. I'm hoping it just runs down mid. If so, that just means I didn't break anything. That's all that means. X, reward, yeah, perfect. Let's watch them. And then what we're going to have to do is we're basically going to have to figure out, like, how to get this thing training high perf and consistently for this dumb task before we try to make it run on something more fancy. You know, because we can start giving them rewards for, like, levels and XP and stuff. But it's not really going to make a difference if the training is not, you know, well set up in the first place. So we're going to look at this, and then I'm going to take a quick second, and we're going to come back and finish that side of things. Okay. These guys aren't doing anything because eval model path PT. There we go. Okay, they go down lane, right? These guys don't. That's funny that Dyer didn't figure it out yet. Well, I think they will improve over time, right? Here, I'm going to launch a slightly longer run. And I'm going to go use the restroom. I'm going to go make myself a shake. And then we will come back and, yeah, we'll see if we can get this thing training way better and more consistently. Maybe, hopefully. Yeah, they should. But the thing is, like, this is a really dumb sanity check anyways. Here, we'll run this for 100 million steps. The problem is at the moment, the configuration I'm running is very slow because the larger one seems to be unstable. So as soon as I get the larger configuration to be more stable, it'll just chug so much more training data that it should work. But it's going to take a little bit of effort to get it to there. So I'm going to leave this up. I'm going to get the experiment up for you to watch while I take a quick minute to go make myself a shake. A few minutes there. Yeah, this run only takes 6 minutes, so that's good timing. Here, reward. Commercial break, more like I haven't had lunch break. Let me go make a shake. Okay. So, the training speed halved. That's new. And it also refreshed so that you couldn't see it. Whoops. Okay, interesting. It goes up to 0.25. Dire level mean, radiant level. The fact that the radiant and the dire are the same levels mean I would think that they are both going towards the center. We'll see when this finishes training, of course. But this looks decent. Yeah. So this was 10 mil before, right? This is where we stopped training before. And then it takes a little longer to get better. Okay. It's not bad. Of course, this is training incredibly slowly. So let's just preemptively start thinking about why that is. When I try to simulate, so the issue is that when I try to simulate way more copies of the environment, which you need to simulate more copies of the environment if you want to train more quickly, has nothing to do with the environment. It has to do with optimal data batch sizes for the GPU. Essentially, like you always want at least 4,000, but preferably 8,000, like 8192 steps worth of data. That's a good mini batch size for small reinforcement learning networks to saturate your GPU. But in order to get that many batches, well, 8,000 steps, that's 10 agents per environment, so that's 800 environments you need to simulate. But in practice, you need to simulate at least twice that number of environments so that while the GPU is running for one set of environments, the other ones are running in the background so that you're never wasting time. That's how this environment here is like taking no time whatsoever. So yeah, that's the awkward part about this. The other thing that's kind of weird is that this doesn't seem to train correctly unless you run multiple updates through the same data. That doesn't make much sense to me either. So we're going to have to play with those. We're going to have to play with those things. This is technically one of the areas where I probably should just run a hyperparameter sweep. And later on in this project, that's absolutely what I'll be doing. I'll just kind of be automating everything. But early on, it's good to gain an intuition for like what things in the environment are wonky and what aren't. So it's worth spending a little bit of time on this, just a little bit. And then after that, we can do, we can do a little bit of reward shaping, a little bit of like just get a bunch of rewards extracted from the environment. We'll look at the DoTA paper. We'll see what rewards they used. And that'll probably be what we'll get done for the rest of today. Yeah. Cheers, though. Almost done. All of this is, oops, right here. All of this is open source right here. Go ahead and start the repo on your way in. Helps me a whole bunch. And the latest dev is right here in anyconfig. You can go look at where the changes are. It's in puffer lib environments, ocean, boba. So all this is available pretty much in real time as I'm developing it. As soon as this finishes synchronizing, we got our model. Okay, very nice. They run at each other down mid. So this is what we wanted. Sometimes they do weird stuff, but for the most part, like there's like one agent that's weird. But for the most part, they do reasonable things. Some of them, they even path around the obstacles on the way there. Yeah. Nice basic sanity check, but reasonable. So let's see how long it took them to learn that. Because we have some additional stats that we can rely on here. Uh-oh. Welcome. Okay, so we can actually see if we look at the training here, we can see dire level mean and radiant level mean here. So they're actually pretty even in this training run, so it might just not be very consistent. But definitely, you only need to train for like 30 million or so steps, it looks like, before this becomes reasonably consistent. And that matches with the reward curves over here. Even 20 million looks reasonable enough. I guess 10 just wasn't quite there. But you train a little longer in your set. So that's not bad. I need to think about why, when you run more copies of the environment, it screws up training. Well, does it screw up training? I haven't tested it lately. Let's change this from 10 environments to 200 environments, right? What happens? That looked good. Hold on. Are we back here? Is it actually working now? Hasn't logged. Maybe that logged. Okay, it only logged us one data point, but logs reward at 0.13. This is not sufficient here. This is only 8 mil steps into training, though. This is substantially faster than before. We can go over 500k here quite easily. But we're debugging, and then there's like some weirdness with the scaling right now. We're going to get this over a mil. Okay, so this is not actually working then, because that 0.14 is insufficient. So then the question is going to be why. I do kind of have this janky generalized advantage estimation implementation. Maybe we need a larger batch size. Maybe that helps. It is increasing, maybe. I'm going to let this run for like a little longer, but then I have some ideas on how I would want to address this. It involves ludicrously large batch sizes. How long would it take to do a sweep on Wandby? It depends. This is an environment for sure that we are going to run overnight sweeps on. It is fast enough for that. It's just that, like, you kind of need to have an initial starting point that's reasonable. Yeah. I'm really only doing very coarse tuning at the moment to, like, get the high-level picture of this thing. Okay, so this thing, it's not... If 50 million steps 0.16 is not good enough, so... One thing I'm suspecting here is possible your reward signal. No, the reward signal is very nice. It's the easiest reward signal in the world. You get 1 every time you go closer to the enemy's ancient, diagonally. You get 0.5 every time you go, like, lengthwise closer to the enemy's ancient. 0 if you stand in place. Negative 0.1 if you go away this way or this way away from the enemy ancient. And negative 1 if you go directly away from the enemy ancient. So, yeah, it's a very, very easy reward signal. Yeah. Should be, like, trivial. 8,000. So this is only 16 steps. This batch size only gives you 16 steps. No, wait. Yeah, batch size tuning. So I have 8 environments. Hold on. I've got 800 environments. So 8,000 agents. Right? No. I have... Did I do this right? 2,000 agents per environment. And I have 8 environments. So I have 16,000 agents total, right? And the problem is that this number is only 8. So you're really not getting very much data per agent at all. Well, we can cut this down a little bit to start with, right? Let's start by just cutting this down a little bit. Do we need 8K? No, Snake runs 1 million steps per second with 4K. We should only need 4K. So let's say we run 100. We run 100 environments per core. So now we are running 800 environments, which is 8,000 agents. We're going to do now, mini batch size will be 4K. That's slightly better, right? And then this is now 16 steps per agent. This is a huge, huge number of updates per batch at this point. Let's see what happens when I do this. And if I can get away with with doing things a little differently, let's say. Am I on the wrong file? Hold on. Yeah, I'm on the wrong one. Well. Well, that didn't run for long enough. And also, that's kind of awkward the way that I did that. I'm going to set this to 1. I'm going to set this to 100 mil. We should at least see the speed come back now. Only 400k. Definitely would expect more than 400k. Some optimization to be done. What's clip frac? Clip fraction is very low. So this big number of updates really is not taking us off policy. Bizarre to me that this doesn't learn. So, that's weird. Why is the training speed that variable? Do I have other stuff running on this box? I don't. It really, there should not be anything variable whatsoever about the training speed. It's not the environment. The environment is not taking up any additional time. Profile it, yeah. Yeah. Well, initially I want to get it learning correctly. Because the fact that this is stuck, like the only setting that I've been able to get to train is when you run very few copies of the environment and you use a lot of stale data. Which, if you think about it, just that doesn't make any sense. It straight up just does not make any sense. I can dramatically increase the mini batch size for more stable updates, in theory. The fact that Ford is taking that much time as well. Stale data, like, I'll show you. So, I had 4 updates before, but like the thing is, if you have mini batch size 4,000, right, and batch size 256,000, then you're actually doing 64 updates times another 4. So you're doing 256 updates per epoch, which is insane. So I'm going to set this to like, what, 32? 32k and see what happens. Does this give you stable updates? I think I have GPU memory for that. This is a task that you should be able to learn in like a million steps with batch size, like, I don't know, 128 or something. It's very easy. Having absolutely no entropy bonus is very jank. But when I remove the entropy bonus before it actually let it learn. What did I end up using for snake? Was the entropy. So snake had an entropy, a final entropy tuned value of 0.01. And grid had a final entropy value of very low. Reward is sum of side 1 plus sum of side 2. Sum of side. The reward is per agent. Each agent is rewarded for going towards the enemy's ancient. That reward is scaled between -1 for going directly away from the enemy ancient and 1 for going directly towards the enemy ancient. So you literally have a one-step reward. Like, except for like obstacles, you have a one-step problem. It's the easiest thing imaginable. Or it should be. But clearly something is wonky here. I'm going to put a little bit of entropy back in, see what happens. Nope. Huh? Oh, that was just a flicker, okay. I'm assuming your multi-agent logic is correct. It's tested on a ton of other environments. Same code. If you want, I can train multi-agent snake for you in like 30 seconds. I tried that earlier today. The snake environment that I have in this in here, you can train like Slither.io basically, 4096 agent snake. You can get a reasonable policy in about a minute. Trains it at over 1 million steps per second. And that policy is basically identical to this one as well. It's just this one has a few more conf channels. Entropy not helping. It's so weird. Blue team goes one direction, red team goes the other, yeah? Now the thing is, I think that the way that, like, okay, here's the really weird thing, right? I'm pretty sure this works. Ocean, MOBA. See. I've got this logic in here that, randomly respawns players every 128 steps. It helps with training. It's like curriculum smoothing. Obviously, you have to take this out later. But if I just rebuild with this, rewards are relative to their respective goals, right? Yes. And you can play this game in human mode, right? And then you can print out the rewards, and you can see that when you go towards their base, you get positive reward, and when you go away, you get negative reward. And also, we've seen it train successfully before, just with really jank settings. Now, if I train this one, I bet this one works. Yeah, so the reward is going up. And all I did is say, okay, agents respawn very frequently. And now you can see you get stably increasing reward with reasonable hyperparameters. All I did. So it's pretty bizarre. And we'll be able to pull this policy down as well and see this, and watch this happen. We need shorter episodes, but why, right? Why does it only work when you randomly respawn agents on average every 32 steps? That's really janky, right? Resets equals training. It doesn't collect full episodes. Just collect segments. Really shouldn't be. It's very weird. Now, oddly, I don't see them getting levels. Hopefully this policy is actually working as we expect it to. I think it is. This is a high enough reward that it should be mostly doing something reasonable. Isn't most RL heavily episodic? It depends on the environment, right? If your episodes... If you have, like, episodes where you have diverse data within each episode, then yes, but, like, you have a dense reward that's essentially just saying go in a specific direction. That should be fine, however you do it. Okay, so this now is trained. And go grab ourselves a free policy here. We'll just render it. Episode versus batch size balance is crucial. It should just be bigger. Batch sizes are better, but it's in practice not always. Here, let's see what this looks like. Funny that they all go down top. Mid would be better. Things are very dumb. It does something, at least. It does do something. Now, technically, I can just... This is, like, passable enough. I can run a hyperparam sweep on it, but... Not particularly satisfying, is it? Can start adding more log variables. I can start adding better rewards. Maybe more difference between diagonal and one step, more like 1.1 and 0.25. I mean, I don't really care which lane they go down. It's just like the fact that they're having this much trouble with such an easy problem is weird, right? Shouldn't be having this much trouble. Have you tried decreasing learning rate? I did before. I got these defaults from Snake, though. And they didn't work. Snake should be a very similar, even actually, Snake is a harder problem if you think about it. Doesn't have as nice and dense of a reward as this. I mean, obviously not the full game of Dota. That's way harder, but just like go down mid. Come on. Well, I guess we should just add in, I don't want to like completely stall on dev today doing dumb experiments. So let's just, let's actually add the types of learning of rewards that we need so that we can like auto-tune everything and we'll go from there. I'm guessing they're just some dumb data bugs. Hold on. I'm guessing that they're just like some dumb data bugs where we're like corrupting observations every so often or something stupid. That's like the usual thing. If reward is so easy, we don't need much exploration. Yeah, we shouldn't need much exploration. We should just be able to like insta-learn it and be done. Okay, I'll cut it in 10. Let's see if it does anything. You're probably right. Yeah. I would think it would be fine with 32k batch though. 32k mini batch. I mean, yeah, but this is still the version from before, right? With 32 step horizons. We'll run the other one after for you. I want to see what rewards they did for Dota. Steal their rewards. Okay. Win. Win 5. Hero death, -1. Courier death, -2. Have an XP gain. Gold gain. We don't have gold. Health change. So they get a reward for healing. Mana change. Killed hero. Gold and XP are very high, so this reduces the total reward. Last hit. Deny. Aegis, Ancient HP. For defending your Ancient, I guess. And then they've got tower rewards. Shrine. Barracks. And then this lane assignment. See item. Okay, so we have randomly assign each hero to a subset of lanes and penalize them for leaving those lanes. This may have not been necessary in the end. Prefer not to do a lane assignment if I can avoid it. Let's see, what did we get out of this? But we're going to implement the tower rewards and stuff. Okay, so visualize none. Here are the last 2 runs. The latest run did worse, it appears. Not really any more stable either. Now we'll run this on the, we'll do the lower learning rate on this one, right? The original task. And then we'll do this while I look more at the rewards and start implementing them. So I think then we do the XP gain reward will be this. $0.002. Oh, there's also the gold gain reward. So golden XP is very high, so this reduces the total reward to 0.4 is what this says. Because this is 0. How's that possible? Doesn't a minion give like 50 XP or something? 0. Was it 008? Killed hero. Well, let's just implement the rewards, and we'll scale them. I think -5 to 5 overall. Looks like something reasonable. How's this doing? Nope, doesn't work. I mean, I told you it's weird, right? I don't know. There could just be something jank about this, like this reward structure, though. I don't. Who knows? Maybe we just implement the full thing and it suddenly just solves Dota. Let's add some rewards. And we also have to cap the rewards, right? Compute. Let me do that first. Cap the reward observation. So plus 8 gives you, is it -5 times 20? Whoops. Yeah, this is good. Initial thought is rewards need to be tuned. 1 for correct and 0 for incorrect. I can do that. I don't know why that would be needed, but it's pretty odd, right? Not having a negative reward. I mean, unless it's like, unless I did something really stupid, like use a uint for rewards, but I don't think so. Let me see. No, it's a float. Should be signed. Okay. We'll rebuild. So I've clipped the reward now to be 0 to 1. Let's see about that. Meantime, we're going to change this logic to be 5. This is just the observation of the reward, so no big deal. We'll clip the reward to... We should do the clipping all at the end, right? They said they get about 0.4 for a last hit on something. So 35, 60 for a creep kill. .006. It seems reasonable. So we add this to the reward here. And get reward based on XP. And then, well, what about the tower? What's there roughly? 2.253, 4.5. I think I can just use 3 for all of these. The baseline, since they're not going to be the same. They also have team-based rewards here, which is interesting. Shrine Barracks. They have Hero Death is -1. Is at the top. Clear this. Did this do anything? Let's see, we tried your experiment here. Oh. This might have done something. Be real interesting. Though it's scaled differently, so I can't quite tell, right? You're at 0.5, but nobody's gotten any levels. Which is a little sketchy. This is really funny. Do you see what they're doing? They're vibrating. So that they're getting a reward every other time step. Isn't that weird? It was pretty weird. They're vibrating along the diagonal as well, which is weird. I don't think that should give them any reward. Yeah, this shows as, huh. Very weird. We probably have some bugs. I have some bugs. Demons. Those demons. -1 for dying. Health changed. Mana changed. We've got tower rewards. We've got XP rewards, and we've got don't die reward. And we also have the the jank reward that doesn't seem to be working. Okay, let's figure out why this jank reward is not working. We got a clue out of this, I think. Which is that this behavior says that it's getting 0.5 reward. Oops, not this one. The one we just watched says it's getting 0.5 reward, right? But I don't understand how. So, distance to ancient. Player Y minus ancient Y plus player X minus ancient X. You move. Really looks like that behavior should get 0 reward. I'm going to implement it locally. What did we say? It was like, if player dot reward less than 0, player reward is 0. That's what we said we're going to do. And according to this, they get 0.5 reward. That behavior looks like it gets no reward to me. Seg fault. I probably just screwed this up, right? Yeah. Seg fault. Okay. Okay, so this is saying we're getting 0.4 reward. It's about what we found before. I do not see how this is 0.4 reward. So, that's interesting, right? Invalid PID. Huh? There. Record has no object type. 5. Type. Key error. I guess I have to update this this asset map a little bit, huh? So we can render it. Where is this even getting? Tile is equal to grid. Okay, so it is the grid ID. That's fine. We just have to update this asset map a little bit. And we'll be able to render it, and maybe we'll get some insight. Just maybe we'll get a little bit of insight. So this is now 2 tower here. 2 is tower. 3. I need to open up this file, don't I? Not this one. Okay, perfect. So this is dire. This is 11, 12, 13, 14, and 15 is going to be the red puff. Was it 128.0? Yeah, so this is the radiant. So this is 6, 7, 8, 9, and 10. And then this one, 256. This is the dire creep. So this is 4. This is the radiant creep, which is 3. And then this is nothing. Because 7 is already covered. Perfect. Why is there no tower? Tower's 2 now, right? Where do we draw the... The walls. Be here. Now we should be able to do it. Yep. Okay. So this is 1. This is 0.5. This is negative. So this is literally 0 reward, right? How are they getting reward for this? Participation trophy? Yeah, seriously, like... Okay, what does it think that the first agent is getting as reward? Let's try that. Zeros. So it's under no impression that this behavior is rewarded, right? What about the Dire? Are the Dire getting rewarded for this bullshit? The Dire are not getting rewarded for this bullshit. Right? 9. So nobody's getting rewarded for this bullshit. Yet we're still doing bullshit. Is that the game here? How are we getting rewarded for this bullshit? 0. We're not getting rewarded for this bullshit. Wait a second. Wait just one goddamn minute. 10. Go. Now we're suddenly getting rewarded for this bullshit again. Ooh. What the hell? So there's definitely a bug with the multiple environments then. Definitely a bug. Which makes sense, right? Reinforcement learning is usually good. Like RL kind of kicks ass. It's usually a data problem. I thought I'd check for this dumb thing as well. Let's see if these agents are doing anything different, first of all, right? Now you're getting 0 again. Now you're getting reward. If I is equal to 1, grid is the original grid. Otherwise, it's a copy of the grid. I'm not going to be able to see it if I do this. Yeah, so this renders blank. And then well, this renders blank. It rendered blank, I can tell you that. So if I is equal to 0, hold on. This gets reward. And this does not get reward. Does that make any sense? Yeah, no, I'm not. This is complicated. It was more or less rhetorical. If you happen to know, then great, but there's something weird with multiple environments going on. Like when you have multiple simulated environments. And it has something to do with the way that I'm passing the map. You set up the grid on a init. Render just takes self-deck grid. Oh, wait. Blocking that. Frickin' bots. You don't sell me bots, I make the bots. That's how it works. So I think I found the issue. So when you pass all this data in, right? What do we do with the grid? We start adding shit to the grid on a reset, right? Oh, I know how we can do this. This is going to be funny, actually. This is going to be, like, horribly, horribly broken. Well... Well, that's a weird number of agents now, isn't it? That's so funny. That's like a top tier bug. Fuck, that is a top tier bug. Jeez. That is nuts. Shouldn't be anywhere else that could happen, though. So, easiest fix for this, I think. That's a top tier bug. It's always game problems, I swear. It's always problems with the game data. Well, this still has some demons, it looks like. Dot copy. Actual freaking demons, I swear. You don't need a doctor, you need a priest. Initial Bowie. Wait, is this Bet? Oh, wait. I just realized this. That's you, Bet, isn't it? Bowie image shows. Shape. 24. I thought it might be. I wasn't positive. Torch shape. Yeah, I bet. Adjusted shape. Image after CNN shape. Is there a bug you're trying to help me find? Oh, it's working. It's functioning. Good. Very good. Carry on. Jesus. Fucking straight demons, I swear. Whew. Just fucking demons. Straight fucking demons. Honestly, like getting good at tensor manips is one of the it's like one of the first things you have to do in ML, and it's one of the things you will use forever in ML. Like that right there was probably like my first 2 years worth of research on architecture dev was just like getting really good at shape issues. Banishing demons. You know? Boom. It trains. Speaking of demons, boxes 4. Are you kidding me? Fuck. 4 and 7. Looking more at box. Don't stress test. His code also. Yeah. Fuck. I'll get him rebooted tomorrow. I'm rebooted in the morning. That's so obnoxious, man. Too many demons. We're not doing Intel no more unless they get some good chips. Yeah, this actually freaking slaps now, doesn't it? $10 M's. Yeah, let's do 100 M's. 200 M's. Boom. We do 8K mini batch. 28K. Which is still ridiculous that that's... I'm working on this thing, man. It's hard. 128. Oops. This is 8, right? Yeah, this is 8. Duh. I don't know why I'm dividing. Powers of 2 on calculator. This is so sketchy the way this works, honestly. You kind of start needing gradient accumulation, don't you? Well, shit. We can do 32K, right? One update epoch. Give us 100 million steps. And let's run a nicely tracked run. Oh yeah, look at that SPS. Fuck yeah. I'll use the restroom, be right back, and we'll see what happens. Got another hour and a half of dev. I have to go run soon. Run is good. Run is kicking my ass at the moment. It's 50 miles per week of run. I'm going to attempt to do 22-mile run this weekend and possibly survive. We will see. So this doesn't work all that well. That's funny. Knees can't. Knees shouldn't be the thing that hurt. Only thing if it hurts my knees maybe is if I try running down hills. I don't run down steep hills. It's usually calves or whatever that or tendons or stuff that gets hurt. Everything hurts. Eventually everything just gets stronger. Takes time. You can very safely train from a marathon from being able to run like a few 5Ks a week in about 6 months. It sucks, but you can do it. You can very consistently do that safely. The training does absolutely suck, though. Marathon isn't that bad for body. 100 miles is bad for body. Marathon is fine for body. Half marathon definitely isn't bad for body. Also good for mind. Yeah, people in shape can just do like, you can do several halves a week and be like chilling. Body's capable of a lot. Interesting that we're still having these weird stability issues. Do I bump the entropy coefficient back up now? It's pretty well crashed, right? Entropy coefficient. Big learning rate. Big reinforcement learning doesn't want you to have fast MOBA. Big RL wants you to think RL is hard and takes lots of GPU. But that's just listening to the man. Oh. We do have 32K MB. 32,000. $131K. 2 M's. We got lambda, gamma, clip. Learning rate is 002. Should be a very easy task. Very funny how this works. We fixed the bug, didn't we? And like forget to pull it, right? And pull. Oh. Yeah. Hmm. Yeah, it's fickle. You fixed the bug with the other thing, though, right? We saw this get solved, like, instantly, right? Could just be batch. The first run we did with this, it solved the, it got, like, reward 0.9 or whatever. So it works. It's just it doesn't work with good settings. Let me try with just way larger batch. That's way, way nicer. I am back. How's it going? Oh man, we found some demons. Yeah, bet this fixed it. It was the effective JE horizon is what it was. Remember that thing I told you about that? Yeah, that matters. We found so Wolf. We found some demons. We found some real demons. So this is one of the craziest bugs in recent memory. Um, I was passing a view of the grid into each environment, and that means that like as you added more environments, it was adding ghost copies of agents into the environment that could get rewards. So like the first environment, which was the one that I was watching, was normal, so everything looked fine, but then like the later environments got progressively more ghosts into them. Yeah, demons. Now this is actually very stable right here. And it makes total sense why. Like Big Batch. This is an actually beautiful RL curve. Look at this. Look how nice this is. Ready? Boom. Perfect. is solid. Yeah, it works. We're going to let this finish. We're going to watch the policy. We're going to admire the policy for a little bit. Hopefully it's good. It looks like it's good, right? Because look at the level means, right? They're doing good, see? They got reasonable levels. They're good. They're kung fu fighting in the middle. We got the training going at 500,000 plus steps per second. Bada boom. Whoops. Thank you for minimizing all my windows. It's exactly what I wanted. That is clean. RL is easy, okay? RL is easy. Making sims that actually work correctly and are fast is hard. RL is easy. You run PPO, you run with some big batch, you run a little hyperparameter sweep, and you're good to go. Let's go look at it. The perfect training curve, which is exactly what should happen, because this is a dead simple task. We train them to go kung fu fighting. Is good. Have you got them purchasing upgrades? Man, there are no freaking upgrades. There's no shop system in this thing at the moment. Let's get them actually playing the game first, alright? Jesus. What's a man gotta do? Solo dev all of Dota in a week? How about this? This looks clean enough, right? Foom. Everyone rush mid. Hiya. Looks good. Everyone feed mid. That's pretty cool. See a bet? I'm gonna keep on this for another hour or so and then go get dinner. This is nice though. How are we feeling about the tower colors? I think they're nice, right? Would be cool to have a 3D viz of it. I mean, we've got... You've seen the human playable one, right? We can play Dota with the bots now. Kind of. Whoop. Key error 5. What's supposed to be on 5? Tower or something? Well, we'll have to figure that out. Yeah, we have it. It is actually human playable. And you're going to be able to play it alongside the bots. What was the fix? Oh, man, Tree. Like, the stream title could not be more accurate. We found some demons. So I was passing a view of the grid, the environment grid, to the C process for each environment, and like each successive environment was adding ghost agents into it that were getting reward or something weird. So like when I visualize the first environment for rendering, it looks fine, but then like every environment after that has more and more ghosts that are just generating garbage reward data. And like eventually we got this weird ass training run where like they were going back and forth in a direction that I noticed shouldn't be generating any reward because they were going perpendicular to the ancient. Like they were going on the off diagonal, and it was showing high reward. So I was like, okay, something's totally wrong here. So I ran it with one environment and it gets no reward. Like, huh, okay, that's weird. The training run says it gets reward, but it doesn't. So then I ran it with more environments and it's getting reward. I say, oh, okay, so then there's something weird with like the multi-environment code. And then like I made a couple changes by mistake and like the reward went back. So then I kind of managed to figure it out from there. It was ridiculous. Hell of a day. But Tree, we've got like proper observations now as well. They can see the type of all nearby agents. They can distinguish enemy hero types. They can see nearby health, mana, and level of agents, and they can see pretty much all of their own stats, like full set of their own stats. So we got some cool stuff now. We got some real cool stuff now. Yeah. Yo, I got a cool idea. Do we want to do... I could change... I don't know if I want to do lane assignment rewards as the thing. I don't know if I want to do lane assignment rewards. On to some features? Maybe. We're doing some thinking. Let's see if we don't have to do resets anymore. I bet you we don't have to do resets anymore. So this garbage should be able to go away. Let's try this. Debugging rewards from ghosts. Yeah, dude. It's like, it's not PhD Doctor of Philosophy. It's like paranormal heuristic detective. I gotta find myself like a fun title that's like PhD initials or something. Because this is like freaking straight up. RL don't need a doctor, it needs a priest. Yeah, instead of a moth in the core memory, it's ghost. It's freaking ghosts and demons and shit. Ugh. It is rough. But I gotta say, we got these real nice stable train curves now. And, oh yeah, it took a while to get it to actually train even after that. Until I, like, upped the batch size massively. I think we've got... Do we have, like, 256 or 500k batch size now? Yeah, we got big batch. We got big batch. And I know exactly why as well, and it's not the reason that people think. You have to go compute the effective... You have to go compute the average number of samples that are obtained per environment. 30k before? Yeah, you have to, like, go compute the expected number of samples obtained per environment per batch, and make sure that that number is long enough to compute generalized advantage estimation over. It's wonky. So essentially, like, just by virtue of the hardware scaling, I have to run... I'm running 1,600 copies of this game right now on, like, 8 CPU cores total. And in order to actually make that work, because I have so many copies of the environment, and in order to get long enough sections of data from each environment in every batch, you need, like, 500k batch. It's nutty. We getting some dire level mean increase, some radiant levels. Next thing is going to be to start logging rewards separately. We're going to separate all the reward components out. It's going to be cool. And then we're going to have, yeah, we're going to have separately logged reward components. It'll be nice. Would you still need huge batches with hyper sweeps? Yeah, we would. We'll need the huge batches with hyperpram sweeps too. We're going to need the huge batches with everything. We'll just have 1 million batch size. Yes. Ooh, reward going down a little? Levels are going up, though. More data. No, not more data, more Dota. Now I want to play some Dota. And I know if I boot that game up, I'm not finishing this project. So I can't boot that game up. Straight up banned myself from playing anything. Like, I allow myself to play Slay the Spire on my phone once in a while. That's literally it. Swear, games are heroin. It's easier to quit drinking than it was to quit playing RuneScape so much. Oh, there it goes. It figured something out. I also had to after over 44,000. Little open TTD. Yeah. 0.04. Where's our reward freaking curve? Oh, there it goes. Boom. RL learned. RL found a way. RL stonks. Invest now. Take full advantage of the RL stonks. Whew. That is some reward. I swear, OSRS is like uniquely heroin as a game. You know, it was the inspiration for like my PhD work on neural MMO. That was the original inspiration. I got it from OSRS. Yeah, I'll go spend 7 years implementing this thing. That sounds like a reasonable thing to do. All right, how are the models doing? And at 0.1% the cost of Alpha Star, this is less than 0.1% the cost of Alpha Star. This is probably less than 0.01% the cost of Alpha Star, mate. Nothing. OSR, yeah. Oops, not this one. We want the high level render. Raylib render. This guy's gotta get lazy. There we go. Fight. They do like to do their rush mid. Oh wait, this isn't the full thing because this one isn't updated. Hold on. To the moon. Puffer to the moon. You too can help Puffer go to the moon. All you have to do is star github.com/pufferai/pufferlib to send the Puffer to the moon. Helps me out a ton. They learned that they can cut through. They learned that they can glitch through right here. Lets them survive a little longer. That's funny. Oh, I'm dancing in your fountain. Started and followed your stuff. Why, thank you. That helps me out a whole ton. So I imagine this is right here is probably what is what's screwing up the learning a bit. They're literally in the fountain. We'll put the We'll put the reset thing back. We'll put it back for now at like a much lower rate. We'll do like 1024. That ought to help. I remember like one of the first games of Dota I played, I managed to feed somebody like 6 levels, and I was like, "What? This is a game where if you don't know what you're doing, you can literally turn the opponent into a god." The ultimate rage bait game. Thank you for the puffer star. We've got... It's been going real well. We're up now to 684, which is awesome. Puffer stonks are good. Okay. Dota's super unforgiving, even more than League. Yeah. Cool game, though. Okay. We're going to show you off some more tech. Want to do some more struct shenanigans? We're going to do some more struct shenanigans. Puffer. All right. C-type def struct entity, yeah? Oh, we don't use this shit. So this can be a C-def, not a C-type def. What else did we give it? Float, we gave it XP, we gave it a death reward. I played Luna. I really liked Lena when I played Dota. I would buy, it's such a dumb build, but I would buy that stupid staff that basically gives you a second ultimate and just like double burst people. But the thing is, I was bad enough that I would just like screw up sausage fingered, like miss all my buttons and just die. uh, and people would be like, dude, press your buttons. Like I can't press the buttons fast enough. I can't press them. It's like, why didn't you ult? Cause he stunned me before I could ult. Cause he's like, I don't know, 14 and on like his 5th Red Bull. uh, good times. Dude, I can't do anything. He's 14. He's on his 5th Red Bull. What do you want from me? He's got those Twitch reactions from like swiping TikTok so much. uh, Reactions are gone at 29. Ah. You know, that's the thing I really liked with old school was like you didn't have to have super fast reactions. You just had to have fast movements with good muscle memory, you know? Like if you can one tick a four-way, which is always in the same position every time, you're good. That took me a long time to be able to do as well. But the reactions, I don't know, I peaked like silver in every other game I've touched. Like, and actually even like, and tried at. Like, peaked silver and like Valorant and like everything else. I didn't play enough League, but I have bronze there. It was ridiculous. I don't know. There's no decision making involved when you can't hit the broadside of the barn. If you just miss, you just miss. It's like, well, you should have like made got a better angle. It's like, well, I would have still missed. I'm just that bad. I don't know what to tell you. uh, oh, OSRS, yeah. It's a lot more. Well, that's a freaking awesome game. I gotta stop talking about it before I want to play it, and then I stop deving stuff. I have stuff to build. Gotta feed the puffer. So what we're gonna do now is we're gonna pull what's called a pro gamer move and make the reward just struct, so that we can get access to the individual reward components in the Python code. What are you adding here? I'm breaking up the reward into components so that we can get the components of the reward in here so we can log them to WandB to see actually what is going on and if they learn to fight and stuff. Okay? And then we're going to add a bunch more logging and stuff, and then we're going to balance stuff, and we're going to tweak things from there. But it's like metrics, visibility, right? Balance, lots of things from there. We also got to put skills back in because I disabled the skills while I was trying to debug. T-type. Team spirit reward for assists and grouping. I think, yeah. That was pretty major. That's for down the line, though. Once we manage to get him to do something reasonable to start. Okay, bro, is it working now? Is there an agent that gets good reward? Oh god, I gotta tell the demon story again. Yeah, so Will, the thing that wasn't working, so when I rendered the first environment in the stack, it looked fine, everything was good. But the thing was, you see, when I was constructing all the environments, I was passing a reference by mistake to the main grid of the env. So what was happening is that each subsequent environment was adding more and more ghost agents into the simulation. And these ghost agents were somehow triggering rewards. So when I would look at it, I had a perfectly reasonable environment, but you actually had this like ghost infested insanity environment that was corrupting all of the training data, And as soon as I fix that and increase the batch size, you get perfect learning curves, and the thing actually freaking works. And, well, I have to rebuild this thing, but... Ugh. Demons. Hiya. The agents shall fly to each other. One or two of them get stuck occasionally, but they run it down mid. There you go. They run down mid. And eventually, it seems that they do take over your fountain. Yeah, this is learned. I just told them to go to the enemy ancient, and they learned to do it. I mean, it's very simple. It's like a really, really easy thing to learn. But still, it works. Oh, towers can still be pulled. I didn't change that. There's an ability in the game that lets you move around towers. See, I didn't add a check on the pull, like the hook ability, like Pudge Hook. I didn't add a check to see if you're trying to target a tower with that. So you can just straight up hook a tower. I saw it happen one time. They pulled their tier 2 all the way back to their tier 3. Get this in Dota ASAP. Yeah, right? Yeah, call me up, Valve, for all of your reinforcement learning and exorcism needs. uh, how long till training on a better objective? It is already technically training on a better objective. There are additional reward components for tower kills, XP gained, dying, and one or two other things. And I'm currently exposing these so that we can graph them independently. That's what I was doing before I was so rudely distracted by demons. So what we're doing is we're putting the rewards into a struct here. I'm gonna put the rewards into a struct. And then is it player obs? Rewards. Whoops. Do reward. Forgot to add that. Boom. Death, XP, distance, tower. That's pretty good. So we'll fix this up now. Cannot assign. Type float to reward. Ah. We don't need to do this. Did I not define reward up top somewhere? Or did I double define it? No. Well, this is bullshit right here. So this is reward. Reward.death. That's better. Get reward of PID. Storing C derivative. I have PID defined, don't I? I totally have PID defined. Well, let's fix these first. These are easy. Okay, now we have 26 values here for reward. Get reward is not defined. Undeclared name not built in, get reward. CDEF reward star, get reward. What? It's right there. So CDEF struct reward. CDEF struct player. Well, cannot convert. So basically all of these are like, we don't know what a reward is. CDEF reward star get reward. Turn and self dot rewards of PID. Self dot rewards equal rewards. Entities. Yeah. I don't understand what the hell's wrong. Undeclared name not built in. Get reward. I literally have it declared right here. Oh, well, this one's easy. This is self dot. There we go. Let's hurry up and make this work so that we can run an overnight sweep. That'd be nice. We just train 10 trillion steps of Dota. That'd be nice. And then we solve it. Out of bounds on buffer axis 0. Get reward of PID. Print. Well. Zero. Out of bound on axis 0. Well, that is ridiculous. That does not make any sense. They're all 0 through 9. So assumedly something is getting passed incorrectly. Num-ems. This is num-agents, not num-ems. Invalid input. There's 26 here, I believe. 26. $26 is what we have. Seg fault. Really? Seg fault? Seg fault's before step. Okay. Seg fault's before that. NumPy.zeros. Oh, wait, hold on. Yeah, I just did this wrong. Segmentation fault. Okay, we don't seg fault there. Though it's possible if I'm putting the wrong data shape in, that would still be a seg fault. Cannot assign float pointer. But before this even happens, I think that's the seg fault right there. Seg faults are dumb. They shouldn't exist. I wish we had C-Zig. That would be cool. Or Pi-Zig. Would be fun. I might take some time to play around with Zig. That might be fun. But the thing is, without this NumPy view slicing thing, nothing's going to be the same. You really need the NumPy view thing. Alright, invalid tensors. Why has I got invalid tensors, huh? Briefly looked at Zig. Is it like C, but with things that make you not cry? Like, I saw that they had a really sweet, like, debug memory allocator that does all the bounds checking and stuff. And then you just swap it when you're set, you just swap it out for the normal one that's fast. That's the type of stuff I want. It's pretty much what it is. Yeah, that's kind of what I want. Of like trendy programming languages that have been going around, I have absolutely no interest in Rust. It's fucking stupid for this. Go is like maybe, but I haven't seen perf on it. I don't think it's as fast as like Bear C from what I've seen. And Zig looks kind of cool. Zig's the only one that looks kind of cool. But then it's like the thing is you need the Python integration here is so crucial. Odin is too much of itself. Yeah. Haven't seen too much of it, but like, I don't want more people reinventing the wheel. I just want like it's very simple. I want C with stuff that I can compile with that makes it not throw garbage errors. That's all I want. Like give me fast compile mode, safe compile mode. That's all I want. Ideally, I wouldn't even have to like put in the code, you know, memory like area allocator or something. I should just be able to compile it with a different allocator backend. That would be very nice. That's where they want to take Zig. If they do that, well, I still can't say I'd use it because, like, the memory view thing, like, the killer app for Scython is not needing PyBind and having memory views. Those two things are just god tier. So like having easy ways to share memory, even structured memory and like entity component systems between Python and C is awesome. And also in this, like I don't even have to write pure C, right? Or stuff that compiles to pure C. I can write slow init functions in Python. I'm allowed to do that. Let me fix the AC real quick, and then we're gonna finish this. Of course, they have to call. They need a name for people that write Zig. I suggested Zigzagoons. Five ten. Is it 510? Flat. Invalid input tensor size. Did I just forget to change something? Beast to re-implement in Zig. As is, yeah. Like it's not. Yeah, it's really not worth it at the moment. Like the Python is best in class by a mile for SimDev. Like this, it's best in class by a mile. Like, you know that there are no mallocs in the Python right now. There's literally no possibility for memory leaks. The errors I get are out of bounds things because, like, it's missing a few compile flags. But all the memory allocation is done from NumPy arrays in Python. It's easier than C and C. Yeah. It's like Python, almost Python ease and raw C performance. It transpiles to C and compiles from there. It's really good. Invalid input tensor shape. Why is there invalid input tensor shape? Is this stupid? Player obs n. Did I calc wrong? It looks fine. What the fuck? Oh, it's because I'm trying to load a model. That's dumb. Yeah. Bunk tried to add. Alright, I figured that it would get stuck there, though. That's fine. Why is this 200 by 2000? Nice. Could not broadcast. Yeah, that's gonna be a problem, isn't it? Slightly obnoxious, really. Just some shape errors. Different ways of representing this. Num agents. Do like this, maybe. Out of bounds, axis 0. On attack, yes, this is going to be an error. It's easily resolved. Um, what's wrong with this? Declare it after it's used. Well, that's a little awkward. I guess technically what you can do is you can put this up here, right? And now that's a null pointer. What you do is you do reward is going to be target.pid. Not initializing? Yeah. So the thing is, it's one weird, kind of awkward thing with Python is you can't declare variables inside of conditionals or loops. So I have to declare it up here and then initialize it down here. Structs work the same as they do in C. So this is a pointer. I've declared a pointer. And now here, I get the pointer to the reward. And now I set it. And then down here, right, this won't have been initialized, so I have to do reward is going to be get reward of this time the player PID. And then I can set that stuff there. So I reuse the same pointer. I love structs. Structs are great. I wish Python had structs. It's one of the worst things about the language is not having good structs. This looks good though. We've gotten a bunch of additional stuff. A bunch of additional stuff here. Structs are great. Type defs are great. Type def structs. I do not know the difference between a struct and a type def struct, actually. I actually do not know the difference. This is nice. So now we get to rerun that experiment from before. Okay. Look at that. We get graphs. Isn't that nice? All these things are getting graphed. We've got a 4-component reward. It's going to be graphed. Makes the struct an anonymous type, so you don't have to declare the struct type when using the struct. Huh. And that works? I guess that works. Yeah, I could see how that would be useful. Oh, I guess I didn't notice that because that's how it works by default in Python. Yeah, in Python you don't have to type the redundant struct keyword anyways. Yeah, I'd forgotten about that. From C. Okay. I didn't know there was a way around that. That's cool. Redundant keywords are just dumb, I swear. Like, languages with tons of redundant keywords are just bad, almost by default, because they just clutter stuff. The other thing that drives me absolutely nuts is typed Python code. Drives me absolutely insane because it's like you're using the slowest language in existence where the main strength is being really succinct and versatile, and you're adding all the bloat of a strongly typed language with zero performance benefits whatsoever. That's my personal just like drive me nuts. I like absolutely hate having to read typed Python code. Win32 API confusion. Jeez. No Win32 API, please. Look at that. Let me sort these. Look at that. We do some, we take some towers. We go get some ancient. We get some rewards. We do a little less, we do some dying, I guess. We get some XP. Yeah? Typing in Python doesn't even... No, it doesn't. And in fact, it doesn't even... Here's the thing. Not only does it not increase performance, the types aren't even enforced. So they literally, they do nothing. And it's worse than a comment. That's like, it's even worse than a comment on the type of the variable because most, like many people don't even know that they're not enforced. The only way that they're enforced is if you run MyPy in strict mode, which nobody does. And even if you do that, you can still technically leak if the entire code base, well, you have to type the entire code base essentially, strict. Like you can't have mixed typed and not typed. It's just horrible. It's just the worst stuff imaginable. Like if you're going to type your Python, you could write it in Python. It would be identical. The types would be enforced and your code would be 100 times faster. Literally that easy. I don't know why I don't use Python's awesome. There are a few little rough edges here and there, but it's so good. I mean, it's the thing that's really funny to me about this stack that should kind of show you. Like, I wrote the snake sim in a week. It's 450 lines of code. It runs at like, I think 14 million, maybe 12 million steps per second, something like that, single threaded. You can run you can run 4,000 one agent snake environment or one 4096 agent snake environment. You can go bigger than that if you want. There are 0 dynamic memory allocations. And there's no PyBind and everything works just perfectly with Python. All right, cool. This was the first game win, so we took a little bit of a down spike after the first game win, but look at that. And then we can go grab our nice model. Training agents to knock down towers. Scython is very good. Scython is very, very good. Like... Let's watch. Oh, look at that. They rush mid. Ha. And they farmed some agents. Yeah, look at that. That's clean. It's funny they don't bother taking the towers. I wonder what happens if we train without the objective to go mid. If they'll like actually learn to play the game. It's really freaking cool either way. We should let's post this GIF and let's get a sweep going. Not getting stuck, yeah. Solid pro mid. Better than some of my teammates. What people say. Yeah, let's see. Da-da-da. Very nice. The response to this project's been decent so far. It hasn't quite blown up on Twitter just yet. It's gotten some decent views. Nothing crazy. Really need it to like hit Twitter proper. I mean, if people like keep seeing it and I keep getting people looking at this project, I'll keep working on it, right? we're at least going to make a stable environment out of it that have some decent policies, right? But like whether I go past like yeah, the agents all kind of go mid, they fight, they look reasonable in the way they fight. They like press their skill buttons and stuff. Like whether I go past that, that's going to depend on engagement with the project pretty much. Oh, I already have this. Perfect. Oh, I literally already set this up. Perfect. Let's see if this works. Invalid hyperparam configuration train. Sweep parameters. Oh. What I'm trying to do is set up a nice hyperparam sweep before dinner. There you go. That seems to work. Okay, nice. So, yeah. Tmux. So that's pretty cool. We've actually got a hyperparameter sweep set up on this now. Hopefully it does something cool for us. Possible I don't have it set up perfectly, right? But we literally have the best hyperparameter algorithm out there now running against this environment. And we're going to get all the results nicely aggregated. Actually, that's already kind of working fast, isn't it, huh? So, I'll explain this, and then I'm going to go to dinner. What we have here... Oops, not this one. It's in carbs. Carbs, sweeps. Okay, so what we have here is a carbs hyperparameter sweep. We get all our usual metrics, but we're also going to get the summary metrics. And this is going to do Pareto optimal Bayesian optimization over hyperparameter space. It's going to do 100 different experiments, or however many until I get bored or whatever. And it's going to give us all the results nicely, and we're going to be able to see if it learns anything cool. I think it's pretty unlikely it learns anything all that cool because we give it a pretty big reward for rushing down mid. So really all I'm hoping to get out of this is that we get like really nice stable hyperparameters that learn to do this very quickly and consistently. But who knows? Maybe they solve Dota. I think actually, paradoxically, I think it's going to do more once we get good hyperparameters. I think it's going to learn more once we remove or substantially decrease the go to ancient reward, because that reward is just like preventing it from focusing on farming or like learning anything else. Yeah. But hey, this is going to be cool. And this is like one of those things that OpenAI could not do this because like their experiments did not run fast enough to do this, right? Like they could do some hyperparameter tuning, yeah, but they couldn't do like, okay, we're going to just queue up 100 jobs, right? And try to like tune that way. That's really freaking hard to do. So we can do it. And maybe we get some cool stuff out of it. I will be back streaming this stuff about the usual, around noonish again tomorrow Pacific. We're going to continue on this. We're going to hopefully keep getting the models better. It's really now at this point, it's more of a data problem, right? We just have to get better training data. So like better observations, maybe a few small network tweaks, hyperparameter changes, and then we're going to clean up and balance the environment a whole bunch and start reintroducing additional features, like reintroducing the skills, reintroducing various other things, and also starting to clean up the environment and hopefully catching a bunch of bugs along the way. That is the goal. Anyways, thank you folks for tuning in. One last appeal, if you haven't already, please go ahead and give this repository a star, pufferai/pufferlib. All the stuff I do is open source. There is currently no revenue from any of this, and it helps me a whole bunch to get this project on the board. Just like the stars, the Twitter follows, like the retweets on stuff, it really, really helps. So that's all I ask. Anyways, have a nice evening, and see you tomorrow.